Good morning, everyone. Thank you so much for joining us. I see attendees are still joining, but we want to get started because we need to stay on schedule this morning. So my name is Anna Stiefkin. I'm the Executive Director for the Wilton E. Scott Institute for Energy Innovation, and we are so excited to be hosting the first ever National EnergyTech University Prize, EnergyTech UP University Prize National Pitch Finals. So I'd like to start first with a warm welcome to all of you who are in the audience, as well as those of you who are judges. So if we can advance the slide. So a special thank you to the Department of Energy, to OTT, et cetera, and National Energy Renewable Laboratory for giving us this opportunity at the Scott Institute. So who are we and why are we hosting? So we are an R1 university, a part of Carnegie Mellon University in Pittsburgh, Pennsylvania. And we have been very active in the innovation and entrepreneurial space for many years. So we've been a part of the American Made Solar Prize and some of the other prize competitions since 2018. So we have faculties who do research in energy and climate tech, and we're very excited about these student teams today. All of our efforts go towards a sustainable, low carbon energy future. I'd like to make sure that you're able to get in touch with us because you can find out about this event and other events in the future by joining our newsletter and following us on social media. One thing I do want to especially point your attention to is end of Energy Week, because all of these activities are a part of Energy Week later this week. So tomorrow, Friday, the 25th of March, between 3:30 and 5 o'clock Eastern, we are hosting a networking mixer, and that is when we will be announcing the EnergyTech UP winners. So you can use that QR code or find additional information on cmu.edu/energy. Now I'd like to pass it over to Joe Simon with the National Renewable Energy Laboratory, who's going to tell us more about the prize today.
Thank you so much, Anna. So again, welcome to this EnergyTech University Prize National Pitch Finals. My name is Joe Simon. I'm at the National Renewable Energy Lab, and we're working to support the Office of Technology Transitions in this program. Thank you so much for joining all of us today. Next slide. Many of you are here today because you're competing at EnergyTech UP, and so you may know what I'm about to say. But for those of you who are the uninitiated, I'm happy to tell you a little bit about what you're about to see today. EnergyTech UP is tasking student teams to develop and present a business plan that leverages national lab developed and other promising energy technologies. This is unique in that it really is about that business plan. It's about the ideas for commercialization, the technology, thinking about the business and the opportunity to change the world. Next slide. Sponsored by the Office of Technology Transitions, this does seek to challenge these students from multidisciplinary teams from across the United States. In partnership with the American Made Challenges, we do want this to be approachable, equitable, and scalable. So we did engage students and teams from all across the country. Winners are chosen based on the strength of their proposal, what you'll see today, not the strength of their background or their resume or their exact technical knowledge of that particular technology. It really is about that proposal. We are very excited to be able to offer over $250,000 in cash prizes. Some have already been awarded to these teams who are our regional winners and National Technology Bonus Prize finalists, but there's over $230,000 remaining available today, including about $100,000 in first, second, and third prizes distributed, as well as $25,000 from each of the different technology bonus areas. This is buildings, fossil energy and carbon management, geothermal, nuclear energy, solar energy, and water power. We thank these technology offices for their support and for encouraging teams to think creatively about advancing the market in these different areas. Next slide. So this is a three-phase competition. Earlier this year, in February, we had about 180 teams present across 11 different regional events. These teams presented to different judges, they got feedback, they heard from each other, and they saw these different solutions. From there, we identified these regional winners, and those teams were then invited to refine their solution. They were provided access to tools like Energy iCore and some mentorship from National Lab or Department of Energy staff, And then today, you'll see them pitch. You'll see them be able to present this business plan, and we'll work with our judges who are on the call to identify between 3 and 9 different winners. As mentioned, we're excited to have a large number of prizes available. First place will be awarded $50,000, second place, $15,000, third place, $5,000, and then each of the 6 technology bonus prizes of $25,000 each. Today, 17 teams will pitch their business plans to a panel of industry experts. After these pitches conclude is when those answers and solutions will be decided. A little bit about the teams that participated. I mentioned this is a national event, and this is the final stage. We have had 180 teams from 113 different schools participate, representing 42 different states, as well as DC and Puerto Rico. This was hosted through partnership and the incredible support of 17 different regional convener partners to put on these different regional events. We're so appreciative of everyone who was able to be engaged, as we were able to see students present their ideas, hear from each other, and see the opportunities that the energy industry provides as they look to grow their careers, grow their businesses, grow their technologies, or grow their futures in any way that they might be interested in. There's so many students and so many competitors and so many faculty, so many judges who all came together to make this a success. And we thank everyone who was part of this, whether or not they are one of the presenting teams today. So on the next slide. I mentioned this earlier, but thank you to all of the judges. Across those 11 regional events, there were over 50 judges who took time to watch those student presentations, ask questions, give feedback, and help those students advance those ideas. So if you're one of the regional judges who chose to call in today, thank you for your participation. Thank you for your support for getting us to this announcement. And then for our judges today. So first, we would like to say thank you. They represent a wide range of energy backgrounds, venture and investment backgrounds, business perspectives, industry or community accelerators, those who help build up this community. And we thank all of you for choosing to participate on this call. So you'll hear from some of them as they ask questions throughout the day, but we have Allison Kopp from UNU, Luke Zahn from @One Ventures, Neka Herbuli from Aligned Climate Capital, Sakshi Mishra from Microsoft, and Victor Kane from the US Department of Energy, or the DOE. As mentioned, you can probably find them all online, but we're so appreciative. They have such a wide range of backgrounds, a wide range of expertise, perspectives in many different energy technologies, many different paths towards funding, many different founder perspectives, many different relationships with the Department of Energy. And together, we think they're very well suited to watch all these 17 different technology presentations and determine the business plans that have a good chance for commercialization. So thank you to all of our judges who chose to participate today. We really appreciate it. So I've mentioned this briefly before, but wanted to summarize it one more time. Our regional prizes. All 17 teams have won a small amount of money to date to really appreciate their perspective, to continue their engagement, and we're really excited to be able to have been able to support all 17 teams that are presenting today. Additionally, we were able to recognize many more teams as Technology Bonus Prize semifinalists. In total, though, what's at stake today is that first, second, and third place prize overall, as well as the technology bonus prizes from 6 different program offices. So as you watch the different presentations, as you watch these different solutions, you can listen. Is this who I might think would be a first place team? Maybe this one is really resonating with technologies in the buildings area, or in the geothermal area, or in nuclear, solar, water power, or fossil energy and carbon management. So there's many different layers and perspectives that you can look at when you go through these different areas. So I think that's most of what I have today. On our next slide, we're really excited to review the agenda and talk about what you can expect. It's going to be a long day of staring at Zoom, so I hope you're comfortable. Grab your favorite warm beverage of choice, maybe a cold beverage if it's a cold brew type of day, but coffee, tea, water, whatever it might be, I hope you have a wonderful, comfortable setup, because we are going to ask you to stare at your screen for a long time. Although in this virtual format, maybe we're all very comfortable with doing so. But this is our gather and welcome phase. Thank you for gathering and welcome. From there, we will go through these 17 teams. The order was determined by a random selection process, so there's no particular rhyme or reason as to which team goes in which order, but we are excited to see all 17. We'll power through the first 17. Each team is given 10 minutes to present with 5 minutes for questions and answers. So we'll go through these 7 teams and then we will take a break. And I would like to note that we would like you to step away from your computer if you can for that break. We will not begin earlier than that 1:30 time. So even if we get slightly ahead earlier, the break might get a little bit longer, but you can plan to return at that 1:30 so that we can all actually step away from our computer, at least briefly, during this long day. From there, we'll have 5 more teams present, a short 15-minute break, and then 5 more teams before we have a few closing remarks. The winners are not going to be announced today, as Anna mentioned. So there's no need for you to stick around and wait. You all get to sleep, not knowing how the competition will turn out. And we do encourage you to join our networking and announcement event tomorrow. This will give us plenty of time to work with the judges to make sure we consider all the different details of your presentation and that we will be able to make sure that we're very confident that the right teams are announced in the right order with the right descriptions, the right titles, the right university descriptions and names and all the other exciting details. That being said, I'm excited to turn it back to Anna as we go to begin our presentations today. Thank you all for joining. We're very excited to have you here.
So thank you, Joe. Caitlin Haas-Conrad is going to be doing most of our introductions today, but I'm going to kick us off with Atom Industries.
Atom Industries, if you can request you, great. You may begin.
Okay. Hi, everyone. My name is Edward Garcia, and I am a part of Atom Industries, and we are excited to be here today to talk to you about our technology and our business model. Let's see. There we go. So our team is comprised of MIT students that collectively possess over 15 years of combined experience in climate energy innovation. This is spanning fields such as nuclear science and engineering, technology and policy, and even business and energy development. We are advised by Jacopo Bongiorno, who is a professor in the nuclear science and engineering department at MIT. And as a team, we have realized that the $145 billion industrial heat market does not have a solution when it comes to meeting their ESG goals and decarbonizing their facilities and processes. This is a problem because not only is the vast majority of heat generated by carbon-intensive technologies, but the demand is also continuously growing. Industry giants across this sector are desperate for a solution since proposed alternatives are not well suited to act as a substitute for their incumbent technology. In the United States, natural gas is the primary fuel for generating industrial heat. And since facilities are continuing to phase out their more carbon-intensive fossil fuel options, natural gas consumption is only going to continue increasing. More importantly, however, industrial heat is the backbone of the US economy. Heat is used for textiles, paper, chemicals, and even food processing. The heat used throughout these sectors are needed on demand in large quantities over sufficiently long periods, or in other words, in base load amounts. It's important to point out that more than half of the heat demand is for process heat applications that require less than 400 degrees Celsius. So when we zoomed in on the process heat portion of the heat demand, we noticed very quickly that the incumbent technology and proposed alternatives tend to fall short in a few key aspects. For example, the leading technology seeking to decarbonize this space is concentrated solar power. While concentrated solar power is easily implemented and is economical and scalable in certain geographies, it is not economically competitive with natural gas, and it is not easily scaled when you factor in the land constraints at these industrial facilities. However, we have a solution that meets these 5 criteria perfectly. It is being designed from the bottom up to be economically competitive with natural gas, easily scaled in part due to its modularity, easily implemented with the existing infrastructure, and capable of providing clean heat and electricity in base load quantities. We are calling it the long-lasting integrable sustainable energy generator, or LISA for short. It is factory fabricated, capable of base load generation, self-regulating, and modular in every sense of the word. LISA is a type of nuclear reactor. It is a plug-and-play heat pipe microreactor that's intended primarily for heat generation with optional electricity generation capability, thus making it an ideal candidate for decarbonizing the industrial process heat sector. From our ongoing primary market research, we have identified the $8.4 billion natural gas chemical steam market as our beachhead. This is a market comprised of industrial heat customers that are very willing to explore innovative technologies because they are not only frustrated with the existing options and proposed alternatives, but they're also facing external stakeholder pressure to make commitments towards a zero carbon transition. Our approach in this market is to establish long-term bilateral contracts for heat that are competitively priced so as to ensure both a cost-effective investment and a long-term set price for our customers. Now, with these contracts or power purchase agreements, we would capture the cost to fabricate, transport, install, operate, and refuel all in a single energy price. Our customers would not have to worry about operation and maintenance, but more importantly, they would not have to worry about any aspect of refueling. We would simply swap out an old unit with a new one and take that old unit back to a central facility where it would be refueled and refurbished, ready for the next location. Refueling would be done in intervals of up to 5 years so as to periodically ensure the optimal operation and safety of our units. The philosophy behind this approach is to ensure that LISA is truly plug and play with the existing infrastructure. This is to minimize the investment on the customer side. We believe that doing so will increase the chances that this sector successfully decarbonizes their processes and systems in a timely manner. Under this business model and using customer data from our interviews, our preliminary levelized cost analysis indicates that our technology is in fact competitive with respect to their natural gas systems. We estimate our break-even price to be around $30 per megawatt of heat, which yields us a sufficient profit margin in the example shown. Once again, under these contracts, the customers will minimize their investments and ensure a long-term set price while essentially only being burdened with the utility bill. But how do we get to the point where we sign one of these contracts? Well, our approach is to first identify target companies, and we have been doing this for our customer discovery process. This is so that we can move forward and sponsor industry conferences where we can continue developing these business relationships while also initiating discussions with future potential customers. After this, we could then conduct demonstrations and host lab visits for these potential customers so that we can effectively move forward and sign competitively priced contracts while selling partial or whole equity. To scale, we would renew these contracts and expand to additional facilities within the same company. With our technology and market strategy, we have identified a prosperous business future with aggressive carbon reduction. What's displayed here is the annual revenue versus percent of the market share captured. This is assuming a contract price of $50 per every megawatt of heat used, thus leading to an estimated annual revenue of $8.1 million per customer per unit. Each customer will need about 5 to 10 of these units on average, and at 100% market capture of our beachhead, we estimate about 90 million metric tons of carbon avoided every year. However, while a go-to-market strategy and a business development strategy are great, this is a nuclear technology. So we have also identified a licensing pathway within the existing regulatory framework that we can pursue. In our identified pathway, we can leverage existing regulatory revisions and policies that are intended to ensure the timely deployment and the timely acquisition of the licenses that we would need. Not only are there existing policies being developed for our technology, but the industrial heat sector as a whole is being pressured to formulate green strategies and to adopt climate energy solutions. For example, the industrial heat sector is committing to aggressive emissions reductions due to increasing ESG disclosure requirements and the high potential for carbon pricing policies. So as we progress on the development of this business, we have defined milestones to track our success. Generally, these are in the areas of design confirmation with respect to reactor engineering, customer-informed design parameters, as well as engaging with the Nuclear Regulatory Commission as early as possible. This is then followed by safety bounding analyses, where we would finalize the design. This is so that we can move forward confidently with the NRC application that would grant us the licenses we need to construct our first demonstration unit so that we can move forward with our first commercial unit and contract by the end of 2027. To get to these milestones, we have also estimated the amount of funding that would be required. The majority of funding for the first 3 years are mainly to scale the operations and increase manpower for our design confirmation and safety bounding phases. For the last 3 years during the licensing process, the majority of the funding would go towards regulatory and licensing fees, as well as the construction of our demonstration and first commercial unit. Thank you for your attention. We are Atom Industries, and with our plug-and-play nuclear energy generator, we believe we can decarbonize industrial heat.
Thank you for your presentation, Edward. As I'm looking at your business plan and hearing your proposition, one thing that came to mind was the challenge of siting nuclear. And it seems as if you are going to be co-located. How are you thinking about the regulatory or environmental frameworks around siting and location choice?
Yeah, so that's a great question. So the part of the reason why we chose the chemical market as our beachhead is because these facilities are not sited near densely populated regions. So we are able to abide towards the regulations, and due to advances in the policies for siting, such as being able to minimize the zones for these reactors, we're able to be much more flexible in these outer skirt regions of population centers. So that's why we're focusing on these more external regions, because the siting is pretty important, but it is increasingly becoming much more flexible with these smaller modular reactors. And those are one of the policies that we are leveraging in our licensing pathway.
Thanks, Edward. Can you dig in a little bit more to the go-to-market and the approach for how you figured out your beachhead? And also, did you survey them on willingness to pay? Did you do any pricing exploration on what that would look like? And then a little bit more about how you're going to secure your first few customers?
Yeah, so when we first started, trying to identify customers, we went head on with the food processing industry. And as a nuclear technology, that is not the best thing to do. So we first went to food processing, and then we started, working outwards from population centers. So we talked to mining, to oil refining companies, and then we landed on the chemical industry because their facilities are, once again, they're not near densely populated centers, but their operations and systems are heavily automated. So there's minimum personnel, and they tend to operate over 24/7 the facilities. So they're the ideal candidate for, or they're the ideal market for this type of technology. So as for talking to these customers, we talk to them to understand what they're currently using. So we know that they're using natural gas. So when we talked to them a little bit more, and they gave us a little bit more insight into how their facilities run, as well as what their cost looks like for their fuel, we were able to determine a maximum price that our technology can be. And right now, with our current data that we have, that's about $50 a megawatt per megawatt of heat. So that gave us the bound for our technology. So we are working towards maximizing the spread between our levelized cost and that maximum bound. For acquiring customers, we have actually been delighted to be received very well. They are excited about this technology, but there are also external interests in this type of technology. So they have also reached out to us to learn a little bit more about what this type of technology can offer them. But what we've done so far is we have already identified a list of early adopters and fast followers that are very open to this type of technology. So as we move forward, we would reach out to those customers and initiate the process to acquire letters of intent moving forward.
I'd love to dive. Oh, sorry, go ahead.
Okay, thanks for the presentation, Edward. So my question is about ownership of the assets. So it seems like you are following the PPA model to set a price for the customers, but seems like the equipment will be sited on customers' campus, and they will be ideally owning it, and then you will be taking care of the O&M and refueling those costs. So how is that ownership of the asset working out?
No, so, and Scott, you can feel free to jump in, but the ownership is going to, the customer will never own this technology. And that's because they do not want to own a nuclear asset on their ledger books. And this is what we learned from our discussions with them. And really, since it's the nuclear technology, it is the most optimal approach for us to be the the owners of this technology that completely focuses on the operation and maintenance, as well as the refueling and any servicing that will be needed over its lifetime. So under this PPA model, it's really just to give the customer a single price that they have to pay. They don't have to worry about anything else. And although it is cited on their facilities, we do have direct ownership of it.
I see. So liability wise, it'll be more on your side and not customers, even though it's operational on their side, correct?
Yes.
The liabilities and risk. Okay. See, thanks.
Thanks. That's all we have for Q&A. BA Tech, you're next. Gavin.
Hello, I'm Gavin Fuchs. I am extremely excited to speak with you today about how our business, Batech Recycling Solutions, will aid in the transition to clean energy. Looks like this, there we go. So as many of us probably already know, lithium-ion batteries are in many of the products that we use every day, from things like our phones and computers to electric vehicles. Looking here very briefly at their life cycle, we can see that their production relies on unsustainable mining practices and extensive processing and transportation. And as a result, demand is actually growing faster than the supply chain can keep up. Currently, only about 5% of lithium-ion batteries are recycled, meaning that the majority do end up in landfills. This is largely due to the fact that current recycling processes are complicated and expensive. So our business aims to address all of these problems, offering a new way to recover the critical components of spent lithium-ion batteries. This process was developed at the US DOE National Ames Laboratory and is patented by Iowa State University. Very briefly, it relies on chemical separation to abstract lithium and magnetic separation to abstract cobalt from the cathodes of spent lithium-ion batteries. So why is this process better than what's already out there? Well, it's more efficient and productive, so it relies on only 3 steps, whereas current processes rely on 5, and it also has higher metal yields of about 70% for lithium and 90% for cobalt. It's also eco-friendly, so it doesn't require any hazardous reagents or produce any harmful waste, and it will promote supply stability by reducing the dependence on the complex global supply chains that are often associated with the mining, processing, and transport of lithium-ion battery critical components. It's also more economic than current processes, so it's cheaper and easily scalable, and as a result of all this, our process is sustainable. So thinking about the sort of demand that exists for this product, I would like to note that the global lithium-ion battery market is valued at about $40 billion, and the lithium-ion battery recycling market is valued at about $4 billion. Speaking specifically about the recycling market, a growth of about 20% is expected in the coming years, largely due to the increasing popularity of electric vehicles and the fact that many of the lithium-ion batteries that are out there today are reaching the end of their life cycles and will be available for recycling in coming years. Additionally, I would like to reiterate that currently only about 5% of lithium-ion batteries are being recycled, representing a huge opportunity for businesses like ours. So thinking then about our sort of target customers, the most direct customer is going to be lithium-ion battery manufacturers. However, we've also included a group here of sort of indirect customers that will also benefit from the implementation of our process. The companies that are actually using lithium-ion batteries. So things like electric vehicle manufacturers, technology manufacturers, and many more. And again, although these are not necessarily the direct customers at first, we do believe that they represent a largely untapped customer base that will be the future of the industry and the key to our success. Our competitors are going to be general recyclers and lithium-ion battery recyclers, those using other methods. And it's also important to note that we will be competing to some degree with the raw material producers and processors who make these components available using unsustainable methods. I would like to reiterate, however, that we do offer a value that our competitors cannot. So our process is more efficient and productive, is sustainable, will reduce supply disruptions, and is cheaper. So I've mentioned a few times now that our process is cheaper, and let me explain why that is. So I would like to preface this by saying that these are estimations based off of the average electric vehicle's lithium-ion battery, as we believe that this will represent the majority of our business in the future. So from 1 metric ton of lithium-ion batteries, we expect to be able to recover about 22 kilograms of lithium and 36 kilograms of cobalt, equating to about $3,500 in metal. It will cost us, however, about $2,250, bringing the total profit per metric ton of lithium-ion batteries down to $1,300, or a profit margin of about 35%. Additionally, we estimate that our initial capital investment to cover the costs of construction of a factory and anything else we may require will be about $35 million. So looking at our revenue projections here, which assume that we will enter the market with about a 0.5% of market share in year 1, which we expect to be able to grow to about our goal of 2% of the market in year 4, at which point we expect to be able to recycle about 10,000 metric tons of lithium-ion batteries. You can see that even assuming a 15% contingency to account for any unforeseen costs, and assuming that our portion of the profits will go to repaying our initial capital investment, we estimate that we need an approximately 2% market share to cover our initial startup costs in 5 years. So risk is part of any business, and ours, of course, is no exception. Looking here at our estimated cost breakdown, you can see that it relies on about 33% reagents and consumables, 26% labor, 5% maintenance, 13% general administration, so things like acquisition and transportation costs, and the remaining 26% for utilities. So being that we aren't reliant on any particularly volatile industries, we expect to be able to withstand an about 50% increase in costs and still remain profitable. So I've talked a lot about, what we plan to do and why it's so important. And I'd like to now go into how we expect to actually make this process available to our customers. So in the first phase, we are going to raise funds and begin partnering with labs so that we can refine our process through pilot experiments. In the second phase, we will continue and finish raising funds and begin partnering with the companies that will allow us to actually begin the construction of our first recycling plant. In the third phase, we plan to actually finish the construction of this first plant, continue investing in infrastructure, at which point we'll actually be able to begin targeting lithium-ion battery manufacturers and actually recycling spent lithium-ion batteries. This is also the point at which we expect to see a positive revenue. And finally, in our fourth phase, we will transition into that sort of indirect customer base I was mentioning before, and targeting technology manufacturers and electric vehicle manufacturers themselves. So speaking a little more in depth about our final phase, we do aim to establish a sort of circular economy model with the businesses that we partner with. So this will mean that in this lithium-ion battery lifecycle here, we will occupy the green portion, providing the infrastructure and logistics to recycle spent lithium-ion batteries and then returning those components into the supply chain to be produced, to be made into new lithium-ion batteries. This process will enhance efficiency across the whole supply chain, as well as result in less need for raw material inputs and produce less waste, as well as in general increase the amount of lithium-ion batteries that are recycled. Additionally, this circular economy model will be integral in establishing a domestic supply chain for these critical components, things like lithium and cobalt, so that we can reduce our dependence on the complex global supply chains that I have now mentioned a few times in this presentation. So before wrapping up, I'd like to go into a few of our impacts. Being that lithium-ion batteries themselves are playing a huge role in the transition to clean energy, it's safe to say that our business will enhance sustainability across this industry and all of those technologies that depend on it. So our process will result in less reliance on rare mineral mining and less pollution at subsequent processing plants. Additionally, across the industry, there will be increased efficiency and less energy and resource consumption across less complex supply chains. Additionally, equity is very important to us at BATTECH Recycling Solutions, and we believe that the transition to clean energy offers not only a chance to build a more sustainable future, but a more equitable future. We know that global warming is impacting disadvantaged communities at much higher rates. And as a result, our circular economy model aims to relieve many of these disparate impacts on those communities. Additionally, we are confident that innovations like ours will continue driving the price for critical components of spent lithium-ion batteries down, therefore reducing the price of lithium-ion batteries and ensuring that in the future, sustainable transportation is available to all. So your investment specifically will be used to finalize our licensing agreement and run our pilot experiments to refine our process so we can enter the market. I would like to thank you so much for listening to our presentation today and for this opportunity and your consideration. And we hope that you are as excited about BATEC's role in the transition to clean energy as we are. Thank you.
No, thank you so much for that. Maybe just roughly speaking, do you know how much it would cost for a battery using your recycled materials versus a virgin battery?
So I do not have those figures, but what I can tell you is that our process will reduce the input costs for those batteries. So what we're offering at the end of our process is the same critical components that are typically made by mining processing techniques, that are required for those lithium-ion batteries. And we know that our process will make that aspect of the battery cheaper. So I can only assume that it would make the general battery cheaper as well.
You mentioned pilot projects as an important part of your process. How long are you expecting these pilot projects to last, and have you identified partners yet?
Yeah, great question. We have not identified any specific partners yet. We do have a few contacts we are working with to get some things finalized, and pilot experiments are important to us because this process is in relatively early phases, and it's important for us to prove our scalability and prove our effectiveness before entering the market. And we do expect this to take roughly 2 to 3 years and cost $1 to $2 million.
So for the sustainability point of view, resource, the question is the resource intensity, how much water and energy usage do you expect the recycle component of the process to take, and how does it compare with other processes which are out there who are recycling lithium-ion batteries today?
Yeah, that's a great question. Thank you so much. So that is actually one of our biggest strengths. So many of the current processes that are out there now, so things like pyrometallurgy or hydrometallurgy, they are largely energy and capital intensive. So they require massive inputs of energy, and in the case of hydro, of water to actually recycle any lithium-ion batteries. Our process doesn't rely heavily on water and also doesn't require any intense energy inputs, largely due to the fact that we don't require any extensive mechanical processing or physical processing prior to our recycling process. So I don't have specific numbers off the top of my head, but I do remember that we expected that our process reduces the amount of water and energy spent by about 60% compared to current processes.
Thanks. Can you talk a little bit more about the funding side of things and how you came up with what your initial funding amount is, and then what it's going to take you to from a milestone basis?
Yeah, so our current funding, our $35 million estimation, is based off of what's available to us and industry standards for similar plants of roughly the same size. So ours is pretty much significantly more expensive than what you would expect for a plant at the current model to build a plant of that size, largely due to the fact that we do have a lot of development and infrastructure construction associated with our cost. So as I mentioned, the initial phase is going to cost about $1 to $2 million to finalize our licensing agreement, and then the second and third phases are the majority of that cost. So the remainder of the $35 million, which will cover construction of an approximately 100,000 square foot facility with the capacity to, over the course of 5 years, recycle about 10,000 metric tons of lithium-ion batteries.
Thanks.
Thanks so much, Gavin. We'll just take a quick moment for the judges to catch their breath here, and future heat, if you wanted to.
While we have a transition, I'll use a transition gap to tell a very
perfect.
corny energy joke. So where do light bulbs go shopping? The outlet stores. The best I can do. Got a awkward smile from NECA, so that's great. So let's see, what else do I have here? Did you hear what the foolish gardener did? He planted a light bulb and thought he'd get a power plant. All right, I hear Jackie. So we're together. We're exciting as we're excited to maybe in the future have events all together. That would be great. But there's another classic one that people have probably heard before. How many software engineers does it take to change a light bulb? None. It's a hardware problem. And with that, I see Future Heat came on video, so I'm going to go off.
Yes, thank you. Can you hear us?
Yes, we can hear you.
Excellent.
Well, good morning, judges, and thank you for your consideration of this competition. I am RT Williams, and this is my partner, Michael Reynolds, and together we are Future Heat. We are both, and we are both chemical engineering graduate students at the University of Utah with over 8 years of experience in energy, design, and utilities consulting. And it's with our personal skill sets combined that we believe we'll be able to tackle the challenges that Future Heat will face. But before we get to that point, I'm going to let Michael get into our issue and our solution.
Yeah, thank you, RT. So we are both based in Salt Lake City, Utah, which is an area that has already seen impacts of climate change. The worsening drought in the Western United States has impacted the Great Salt Lake itself, which is drying up. We also suffer from air quality caused by inversion conditions during the winter, where our current policies are targeting carbon reduction to help alleviate these issues, but that forces the need for our energy practices to adapt away from the current source of fossil fuel heating in the built environment. In general, businesses and homes here are heated by natural gas furnaces. That natural gas will not help us achieve carbon reduction targets into the future. And so for that reason, we've targeted a technology of cold climate air source heat pumps. Cold climate air source heat pumps are a technology that uses electricity to heat and cool buildings rather than natural gas combustion in a furnace. The Building Technology Office indicates that about $1,360 of incremental cost for a cold climate air source heat pump over a traditional furnace. Market research conducted by the Northwest Energy Efficiency Alliance has indicated that decision makers are willing to pay a reasonable incremental cost, provided they are aware of the technology and its merits. For a cold climate air source heat pump, those merits include reduced utility cost over the course of the life of the equipment, because it is a more efficient technology for heating and cooling. We have the fortunate pleasure to work with the GIVE Development Group here in Salt Lake City, which is a development group that builds, designs, and operates low-income, all-electric, multifamily apartments. And their construction practices have showed that they are able to construct an all-electric building at a lower upfront cost than a conventional furnace-fired and natural gas water heater building. Their most recent project is called Diamond Rail. It broke ground in 2020 and has recently begun operation. They were able to build Project Diamond Rail for $133,000 less than an identical set of building plans with furnaces and gas water heaters, saving about 1.1% of their overall construction costs. So why aren't more businesses and developers following GIVE's example? That's because there is this existing perception that cold climate air source heat pumps are a cost-intensive alternative to a furnace. This is caused by an ignorance, a lack of knowledge about the benefits of cold climate heat pumps. And why aren't they able to see these benefits? Because most developers don't have the resources to develop the comparative analysis necessary to make an informed and wise decision about heating and cooling technologies. The solution we propose is Future Heat. Future Heat is a consulting engineering firm that specializes in the design of electrified HVAC systems through energy modeling and economic analysis. We offer connections to installation and subcontractors specialized in cold climate air source heat pumps to help aid the initial installation and operation. We also offer continued support through ongoing system optimization, reporting, commissioning, and assistance towards energy certifications and awards. We feel that the market in Salt Lake City and the Wasatch Front is ready for this. According to the Ivory Gardner Research Construction Report of Q4 2020, the value of the market here is about $6.7 billion in residential construction. The forecast was about 30,000 residential permits issued in Salt Lake, in the Utah market, and about 90% of those were for apartment buildings in Salt Lake City. We see every single one of those residential permits, those residential units, as an opportunity to push cold climate air source heat pumps. We also see immense opportunity in the single family market for both new construction and renovation, but we're focusing more on these multifamily developments because we have this case study that shows that it can be an upfront boon. Our market size estimates that about 69% of that $6.7 billion market is in the Wasatch Front region of Weber, Davis, Salt Lake, and Utah counties. We anticipate being able to reach 30% of those developers, giving us an available market of about $1.4 billion. It's common to see about 5% of a developer's budget devoted towards consulting and design fees. So we see an obtainable market of about $69 million for our region. We propose to target this market by working through our existing partners. First and foremost, through the GIVE group, to connect with other developers who are interested in emulating their success with electrified construction. We are also both alumni of the Industrial Assessment Center, which gives us experience in the Energy Analysis Center. In energy analysis, we propose to work through them as well to reach new customers. We're also partnered with Rocky Mountain Power, our electric utility, who has set policies and goals to electrify the market and to incorporate energy efficiency and grid responsiveness into new construction. We also propose to reach professional associations of home builders and energy and building designers and building operators and managers to identify those who are building and interested in working with exciting new energy technologies. We see our competing interests in this field as being the natural gas utility here in Utah, which is Dominion Energy. They have an interest in continuing to use natural gas as the heating source of choice. Natural gas is business as usual, and Utah is a fossil-friendly state with significant production. We see this in the market currently with support for dual fuel heat pumps, which use natural gas as a backup heating source with a heat pump installed. We also see competition from existing mechanical and architectural design firms. Oftentimes these businesses have in-house energy modeling capability, but they don't focus on project initiation to project completion and building completion.
So as Michael discussed, our competitors are only focusing on one aspect of the sector or the consulting phase. And this is one of our competitive advantages. We're fusing energy and economic analysis at every stage of the development. Additionally, becoming partners with these developers from the initial design development all the way through measurement and verification, or M&V for short, of the finished building. Meaning that we are providing a more well-rounded and better product at competitive pricing compared to our competitors. Additionally, we have a supported research partnership with GIVE Group, which allows for business growth, longevity, and even implementation of novel design methods, which continues to separate us from our competitors. Our revenue streams are threefold. The first will be energy modeling, which will be fixed price based on the expected engineering and labor and size of the project. And these costs will be offset for the developer by incentives offered through Rocky Mountain Power up to $15,000. Next, past that phase will be design consulting, which will be negotiated with their clients, but will be based on hourly rates and help with their construction to smoothly integrate electrification strategies. And finally, our M&V services, which will be a tiered subscription, depending on what their needs are, and was comparable to our competitors in the industry, while again providing a better product. Our cash flow timeline is also threefold. In our first couple of years, we will acquire licenses and software, begin our outreach through partnerships, and initiate development projects, ideally 3 to 4 after our first year. Past that, we will finalize our first projects, work through our established and repeat clients to land more work, ideally 2 projects per month, again, comparable to industry, and finally begin delivery of our tiered MAB subscriptions. With this in place, past year 5, we see a sustainable cash flow from our ongoing subscription service while bringing new cash flow from repeat customers and advertising or outreach. But we can't do it alone. With your investment, we'll be able to acquire relevant technical training and certifications, such as professional engineering licensure. We'll have the capital for professional grade energy modeling software licenses, such as Design Builder for Energy Plus, and we'll be able to establish an engineering firm based in Salt Lake City, able to handle the overhead costs in doing so. And your investment is not just in the 2 of us, it's in the greater area as well. We will help city and state officials meet carbon reduction goals. Utah citizens will breathe better air quality as a result. As we've mentioned, developers and builders will save costs and streamline construction schedules. And very impactful is that tenants and owners will also see benefits, especially in low-income housing. So join us as we cool and heat a better tomorrow with future heat. Thank you.
Thanks for that awesome presentation. Can you go a little bit more into the services itself? So tell us more about the energy modeling process, right? Is there anything that you're doing that's proprietary, that's different than what other design service firms are doing?
Energy modeling is a process that basically builds a digital twin of a building to be constructed based on construction documents. And so using those proposed designs, we can simulate the amount of energy required to operate that building through its heating and cooling cycles based on weather information compiled by the National Centers for Climate. So that helps us to evaluate the benefit and impact of different design considerations in a building, whether increasing the number of windows or other things will result in more or less energy use. It's especially useful when comparing different HVAC equipment systems. So we propose to model these buildings to show how much less energy an electrified system can use for this building, making a direct comparison to a traditional natural gas system. So that kind of allows us to simulate the performance of the building long before it's built, helping developers to see the benefits of choosing one path versus another before they've invested significant time in developing mock-ups or investing any part of the construction process.
Awesome, thanks.
Do you see this as being more of a service for helping developers working on new builds deciding on whether, like, which HVAC system to use, or would this also be relevant and valuable to potential retrofits?
It is valuable to both retrofits and to new construction. We're focusing on new construction because we're seeing a boom in that market here. Housing affordability is a major issue in this market right now, but it is also beneficial to retrofit situations. It's just a lot easier to design in the required extra electrical load for a new construction than having to retrofit it through a complete gut of an existing apartment building.
Have you contemplated the scaling prospects outside of Utah? So market analysis I saw was Utah centered, like Energy Plus and Open Studio. There are practitioners and consulting firms out there. So how do you differentiate yourself from that and see growing from outside Utah?
We do see an immense market in the cold climate region. Almost all developers are active in multiple markets, and through the development partnerships we plan to bring on board, we hope to expand to markets such as Chicago, Denver, and Boise as our preliminary targets. Those are also markets that are within ASHRAE climate zones 5B and 6B, which are cold regions that experience significant amount of the year under 32 degrees Fahrenheit. So we see those as very appropriate additional markets, which are larger and face the same climate-related issues that we do here.
Thanks.
You had indicated a subscription model, a subscription revenue model, but do you see value in getting into the project development side or expanding into the roles that your current partners play?
There is benefit there. We prefer to stay on the side of the engineering consulting rather than the project management and construction management. We can help manage the subcontracts for the installation of the cold climate equipment, but we don't want to get as much into the plumbing design, the envelope design, or some of these other areas that would be expected from a full service design build general contractor.
Great, thank you so much, Future Heat. Do we
Thank
have
you.
Miami Best? All right, Miami's Best, your 10 minutes starts now.
Hi, I'm Kara Samuel,
I'm Alexander Ezzi.
and we're here to talk about the future of structural piezoelectric supercapacitors and their impact on electric transportation and energy transition. So a structural piezoelectric supercapacitor is a lightweight energy storage device with high power density, low resistance, and ultra-fast charging capabilities. It combines the function of physical structures and batteries into one device, and is made of carbon fiber material that's able to replace the physical structure while providing usable power. It's also 17.5 times stronger than steel by unit mass. And this piezoelectric film provides extra cell voltage, induces self-charging capabilities, and increases the maximum power output and energy density of the device. So you can see that the piezoelectric films increase the cell voltage from 1 to 4 volts. We have a 98% charge discharge efficiency, low resistance, and a 20 kilowatt per liter power density compared to a 0.25 to 0.34 kilowatt per liter power density of lithium ion batteries. So we tend to outperform them in these metrics and other batteries as well.
So who will buy this technology and why do they need it? Currently in the US, the transportation industry accounts for the most greenhouse gas emissions at 29%. Big decision makers like Ford, Boeing, and the US Department of Transportation are our main customers who have the greatest impact on these emissions and would be responsible for delivering our technology to the end user, which is anyone who drives a car, takes a public bus, or flies on an airplane. Our focus here is on serving the decision makers' needs. Structural piezoelectric supercapacitors can solve a lot of problems in the current market while positively contributing to the energy transition, which we will explain in the next few slides.
So the aviation industry really needs this technology because they output 95 billion gallons of fuel in 2019 alone, which is $190 billion for 1 year. So if these structural supercapacitors could only power takeoff, airlines would still save 10% of fuel each flight. Additionally, the decreased weight could help them optimize flight storage and emissions as well. Additionally, a big thing is our technology can function with 100% capacity in low atmospheric temperatures. We see around negative 22 degrees Celsius in air, and our range is about negative 40 to 150 degrees Celsius, while current batteries like lithium are around 14 degrees Celsius to 86. So we outperform them there.
The electric transportation industry can benefit immensely from rapid charging times, increases in acceleration and range, and a higher functioning battery system under extreme temperatures. Some current competitors in the market include hydrogen-powered fuel cells, traditional lithium-ion batteries, and other thin supercapacitors, with notable companies like Tesla and Maxwell Technologies. It is important to note that our supercapacitor can work in conjunction with these batteries, as well as replacing an entire battery system.
So how are we helping our customers and businesses better serve the market? By increasing the payload and optimizing flight efficiency, we can help the cargo industry. By reducing the emissions, we're providing a more affordable airfare for the mass market consumer, and our turbocharge will cut refueling delays. So that will also be better for anyone flying a plane. Automobiles, similarly, we're working on safety for the consumer by eliminating overheating and temperature malfunctions. We're going to provide them with the turbocharge in under 5 minutes, almost like filling your gas tank. And the powerful acceleration can be vital for the racing industry. And finally, public transit, the fuel cost savings can be redirected for city budgets, and that our customers can bring that to the market. And it's a perfect application for the quick acceleration and deceleration of trains and buses. So to do this, we're focusing on licensing deals with our main customers like Ford and Boeing, who are eager to innovate and lead the clean tech space, but kind of need an advantage and a way to compete with big players like Tesla. So we'll do this by continuing research and development, obtaining patents and intellectual property rights to protect our technology, marketing through the academic community, continuing to enter into competitions and showcases, and exploring relationships with investors and industry experts. So we will rely on our partners to deliver the structural piezoelectric supercapacitors to their customer base in a final product form, and we will deliver our technology to our customers by accomplishing a licensing revenue model and these intellectual property agreements.
So typically, companies like Honda and Boeing spend a lot of money on raw materials and manufacturing. Although our technology utilizes expensive chemical ingredients, much of this structural material is being substituted with our supercapacitor. And so some of these costs are offset, and fuel costs are also reduced. A company, Eviation, recently spent $4 million on a lithium-ion jet that could provide major cost savings for the user if scaled to a commercial size. We know we can have similar cost savings for the user with fuel cost reductions and elimination of expensive extraction techniques. Typically, planes are more expensive to manufacture and fly the heavier they are. So ultra lightweight carbon fiber would minimize this expense. We also see that Tesla users are willing to pay a steep price for electric vehicles. Companies like Ford, wanting to compete in the green energy transportation space, have designated millions of dollars for energy storage devices and related technology. We can give them a feasible competitive advantage while maximizing their profit margins. So how much will it cost? Currently in the lab, a 2.5 by 25 centimeter supercapacitor costs $10 to manufacture. And we expect when mass produced, we can reduce this cost to less than $1.
So in summary, our main costs are our patents, our ingredients, and our laboratory facility costs, mostly with research and development. And the consumer costs will be the royalties they pay to us. And then they will deal with the manufacturing and production costs, including the typical testing expenses for their safety testing, et cetera. So to prepare for commercialization, first, we'll need to utilize our research grant to fund the production and operations in our campus lab. But once the product is ready to be marketed, we're going to move lab facilities and continue optimizing and adapting the device for specific customer needs while working on other products. So we want to raise at least 1.2 million to acquire this small new lab facility and the equipment, and $50,000. And if we win the first prize, we will go towards obtaining multiple design and utility patents. So the timeline is a little rough because it depends on how quickly we obtain these partnerships, but we expect that by 2023, the technology will be protected and ready for market. Before this, we want to raise at least 100,000 debt-free from competitions and benefactors. And after successful licensing agreements, it could take about 1 to 3 years to reach market, meaning that we might not see profitable quarter until 2025. However, we can break even pretty easily with a lot of debt-free investments and depending on how we set up our licensing agreements.
So who benefits if we succeed? Transportation industries and future generations of people worldwide that suffer consequences from human emissions.
So the impact on disadvantaged communities. First, by reducing the aircraft costs, we're providing more affordable airfare tickets. We are also replacing fuel extraction jobs that have been eliminated. But most importantly, by partnering with the U.S. Department of Transportation and powering buses with these structural supercapacitors, we could yield a cost savings of about $458,000 per bus over its lifetime, which we can then redirect to urban and city budgets. Additionally, electric vehicle city school buses in the summer can be plugged into the grid and alleviate electricity costs for these low-income communities.
So our role in energy transition and sustainability is in helping eliminate barriers in the mass adoption of emission-free technology and facilitating transition of power sources for vehicles. How we define success: improving energy density of our supercapacitor, achieving commercial adoption via licensing agreements, having positive environmental financial impact on urban communities, and again, having a major impact on energy transition in multiple sectors and applications.
So of course, we need more funding and support for us to conduct further testing. To the left, you see a picture of a structural piezoelectric supercapacitor RC car prototype that we're making in lab to show our proof of concept. So again, we also would need the larger manufacturing laboratory facility, licensing contracts, the patents, the intellectual property deals, but most important is maintaining long-term relationships with partners to support the sustainability and growth of our business, and eventually become their sole provider of these supercapacitors and other clean energy technology that we'll produce in the future. And we will take all of our resources and revenue and funnel that back into research and development to extend our market share and widen our scope of products. Thank you.
Thank you for your presentation. Given the complexity of the technology, or maybe I'm overstating the complexity, what are you imagining the switching costs to be for your partners that will be licensing your technology in terms of changing their manufacturing or current operations?
Right. So initially, our goal is to not completely change the way that they make their cars or electric vehicles. It's to add and improve the way that their electric vehicles work. So, typically, you don't have to supplement the entire structure to utilize the supercapacitor. And the way the technology is right now, it currently is not able to function just on its own. So if we use this in addition to lithium-ion batteries, then obviously there will be an added cost. But like we said before, when we're supplementing some of the structural material, then a lot of the costs will be offset, and it will continue to increase like the efficiency of the car. But we don't have an exact number of how much it will take if they were to completely substitute their current technology. But a lot of our customers are ones that have not started that process yet, or are in the early stages of that process, looking to compete with people like Tesla.
In terms of the heavy transport use case, such as aviation, how do you see this sort of stacking up from a technical feasibility perspective, or maybe a cost perspective compared to other decarbonization options like hydrogen fuel cells or biofuels?
Right. So currently the lithium ion and fuel cell batteries are 60% of the weight of the aircraft. So they're extremely heavy, which is why you're only seeing small jets, 9-passenger planes, things like that. And if we want to use electric technology for cargo planes, commercial planes, we need to improve the payload, otherwise decrease the weight. Obviously, you have to worry about things like weight distribution and such, but using the structure as the actual battery and diminishing, any type of other supplemental battery, lithium in the actual plane will make it scalable and able for us to change the size and eventually accommodate those things. Did that answer your question?
So seems like you're targeting R&D and its growth, and then stopping at the point where you will be licensing out the technology and royalties will be main income stream. So do you not plan into getting into manufacturing O&M sides of things?
Yeah, so right now, we kind of showed that RC car prototype. And that's like the whole idea is we want to manufacture a product, show our potential licensing partners that it is possible to integrate into a battery system. But in terms of like a manufacturing facility, we're going to leave that up to the actual licensing partner, because we don't know exactly how they want to implement it depending on what they want to do. But in terms of like manufacturing, yes, we will make prototypes for them and assist them in that process. But yeah.
That will depend on, contract manufacturing, which it will be based from partner to partner, whether they decide. Like someone like Ford, they typically have like their own engineers and internal manufacturing. So they would just benefit from us giving them the free range to use that product, showing them how to use it. But maybe a smaller startup company might need our help with the manufacturing. In that case, then we would think about transitioning into that space.
And I'd just like to add that like foregoing that manufacturing on a large scale allows us to be pretty adaptive to the market. So if we want to explore a new option, we're not stuck in manufacturing this one specific shape or such like that a lot of these big conglomerate companies are.
You mentioned markets, auto and airline, which are two relatively distinct large markets. Can you talk a little bit more about your go-to-market and which one are you approaching one first? Are you doing simultaneously because it's a similar product? Can you talk a little bit about that?
Right. I think our approach is probably first to do the automobile, like electric vehicle, because currently that's what we're working on in the lab is making that RC car prototype. So there's just more of a proof of concept that we can physically show them. But we want to simultaneously go into the aviation industry because currently carbon fiber and a lot of these materials are already used in aerospace settings. So it's not like out of left field that they would adopt some type of technology that has similar materials that they're already using. So that answers your question.
Yeah, thank you.
Thank you so much, Miami's Best.
Thank you so much.
Electromame.
And while you come on, I'm going to take over and say a joke that I don't have one for structural piezoelectric supercapacitors, but I do have one for heat pumps. And so my wife and I just got a new heat pump installed in our house, and I was trying to explain how efficient it was, how amazing it was. She was not that excited about it, but I just said it's super efficient. I'm super pumped.
Yeah, there we go.
All right, Electromame, we can see you. We have your slide deck up. Your 10 minutes starts now.
Hi, I'm Dylan Casson.
I'm David Friedland.
And I'm Emer Johnson. And we're part of Electromame. Electromame installs micro-hydro generators in buildings' water systems to save building owners, managers, and tenants money while drastically mitigating our carbon footprint. Every day, millions of gallons of water are pumped up and down the tall buildings that dot our city skylines for washing hands, getting a drink of water, taking a shower, or even going to the bathroom after downing a double espresso. But for water to be distributed to every unit of a tall building with adequate flow, the water is initially pressurized to extremely high rates using pumps in the basement of the building, so that the top floors receive water at a decent pressure. However, if this water was to just siphoned off at any of the units below the top floor, it would burst through the faucet, break toilets in half, or severely injure an innocent shower. For this reason, devices are installed to decrease the pressure to safe rates. This depressurization is achieved through the dissipation of excess energy into heat. This creates a net loss of energy, having a detrimental impact on our climate, not to mention the wallets of building owners, managers, and tenants. This antiquated system wastes gigawatts of energy every second globally. To put that into perspective, 1 gigawatt can power roughly 750,000 homes, or a little under 10 million light bulbs. In addition to exacerbating the ongoing climate crisis, this process wastes energy in urban areas which are already acutely threatened by forced power outages and blackouts. As a result of urban consumers being far away from where the energy they consume is produced, weak transmission lines, overwhelmingly common in low-income areas, often malfunction, causing blackouts or necessitating power companies to focus supply elsewhere. This can range from hours to days on end, disrupting education and bringing local economies to a standstill. These forced power outages are described by some analysts as one of the key stumbling blocks in the way of improving the quality of life in low-income areas. By focusing on a way to produce clean energy in the heart of urban centers, we can eliminate this epidemic. This is where we come in. Electromame installs and maintains micro-hydro generators to be used instead of pressure-reducing valves. Our solution allows buildings to mitigate energy costs and profit on excess energy produced by sending it back to the grid or repurposing it within the building. In-pipe hydro generators have been installed and tested in a number of use cases. For example, in underground water mains for the same reason. However, as opposed to the invasive nature of installation that entails, that being the tearing up of roadways and lengthy municipal bureaucratic approval processes, micro-hydro generators in buildings can be installed with ease and produce similar results. Additionally, our solution is proven to require less maintenance than PRVs and can be installed directly in place of them while eliminating another cost for the building. While PRVs address excess pressure by dissipating it in the form of heat, hydro generators utilize the high water pressure and convert the excess into electricity while still allowing for adequate pressure on any given floor of the building. In doing so, less stress is put on the plumbing system while also recapturing the energy which is traditionally lost through this process.
As you can see from the flow chart shown here, the installation of our solutions is very simple and truly plug and play. Our hydro generators are used directly in place of the pressure reducing valves, We can customize each hydro generator in order to fit the right size and specification of the PRBs in each building. We have built relationships with several generator manufacturers as well as installation teams. Ultimately, we hope to manufacture our own generator customized for this purpose. However, given how common this technology already is, it would not be difficult to utilize outside manufacturers. The value of us having forested relationships with a diverse group of manufacturers is that it provides us a major advantage of access to a number of differently sized hydro generators to choose to install based on the configuration, specs, and size of the building. Our market, our solutions can pose an immense benefit to all kinds of urban buildings. As we know, many people are currently looking for more efficient buildings, and that starts with improving the building itself. Just to give you a sense of how big our market is, there are 297 high-rise buildings in New York City, let alone another 512 in Hong Kong, as well as 132 ultra high-rise buildings globally. After speaking to these building owners, about 80% of them are currently, as we speak, looking for a better solution. This gives us a huge advantage, being able to implement our product fast. When you think about those 80% of people we spoke to, about 100% of those owners stated that they settled for unprofitable solutions. What this means for us is that there is already an open market. With a statistic of 100% of people saying that they settled for less, our product becomes more desirable. Our team's customer discovery has validated a section of enormous market building owners, managers, and developers. Due to compounded pressures of increased environmental regulations and a national $10 trillion of building infrastructure necessitating upgrades, 80% of building managers we interviewed are scrambling to find alternative revenue streams, especially those of multi-tenant commercial buildings facing an unprecedented number of vacancies. So while we can produce an immense benefit to all mid and high-rise commercial, residential, and municipal buildings, we plan to first start marketing our solutions to multi-tenant commercial buildings that have a remarkably acute need for our solutions due to unprecedented COVID vacancies.
Given a new set of efficiency calculations found by our engineering team, we've determined that for just the Salesforce Tower located in San Francisco, the savings would be upwards of $285,000 a year, given the energy cost in that area. Now, for reference, this tower has been completed for a mere 4 years, but had this technology been installed in the tower from its inception, the tower owners would save north of $1.1 million for doing nothing more than they currently do. Our customer discovery has also informed our marketing strategy by directing exactly where in the procurement process to inject our solutions, namely meeting with building managers, owners, developers, energy management firms, and utilizing the conferences and organizations which inform our customer segments. Competitors in the energy management technology field offer few profitable solutions, and those that are profitable, like solar panels, are more expensive and invasive to install. These generators, however, already exist, have been tested, and the installation is simple, but no other company has taken the opportunity nor built the necessary relationships with manufacturers and installers to make this a profitable venture. Today, we have the opportunity to change this. Electromim offers an inexpensive and simple solution to a massive market, which can utilize the technology on a scale grand enough to create a substantive global impact. The financing of these installations constitute various upfront costs as well as royalty fees. Our preliminary revenue model is based on calculations from the engineering team using projects with pre-existing buildings and new developments. While our projections like $4 million in revenue in year 1 and $15 million in revenue in year 2 might seem enormous, acknowledging the size of the market and after a successful pilot program to incentivize the solution's adoption, the figures are indeed realistic. As indicated, by applying this technology to mere 2 projects, while admittedly larger projects, the potential upside is massive. Though our engineering consultants from the GWU Engineering School have proven the feasibility and potential profitability of our solution on paper, we need approximately $100,000 in Kickstarter funding to finalize our laboratory testing and proofs to immediately begin our first pilot project, which would accelerate our sales process and make this a reality. Looking at our team, it's comprised of myself, David Friedland as the COO, Dylan Casson, CEO and founder, Amir Johnson, CMO, Lila Childs, Chief of Design, Yoel Golko, CFO, Ryan Welch, engineering consultant, and Ben Shishik, engineering consultant. Looking at our team makeup, most of our team members are undergraduate students studying varying fields, but this has actually proven to be an invaluable asset as it's opened up varied doors for customer discovery. Additionally, our team of PhD students from the engineering school has helped us on the technical side. However, we hope that you too will join our team in its mission to not only save building owners, managers, and tenants money, but the planet by furthering our efforts in the shift towards energy efficiency.
Admittedly, these solutions will not change the world in the blink of an eye, but will play a vital role in trying to. Thank you.
Thanks for that. What would be the payback period for your customer if they were to switch over to one of these systems based on the energy savings?
So again, because it's based on the specs and the size of every building, it does vary, but it would be basically anywhere between half a year to 2 years.
Okay.
Can you tell us a little bit more about the funding? So 100K to me, just based on the technology that you're building, seems low. So I'm curious what it's going to take to get to real, true commercialization so you can start recognizing that revenue that you talked about.
Yeah, so surprisingly enough, because we're using micro hydro generators, the price is a lot cheaper than you'd think of when you're looking at like the whole hydropower industry itself. So it's about $25,000 of that would go to the testing and kind of the research and development of that part. And then the other $75,000, we've already analyzed a building and given a solution that's how much it would cost for our first pilot project. So that would be the cost of installation, the cost of buying the units themselves. And yeah, that would basically finish our first pilot project completely off.
And then after that point, we would be, funded by profits from those prior ventures.
Thanks.
And on one of your slides, you had mentioned that you can make a profit. I just want to clarify that I didn't miss anything. Is that the savings or there's an additional revenue generation opportunity for them?
For the buildings or for the company itself?
For the buildings.
For the buildings, it is the energy saving that is the profit there.
Great. And then in terms of kind of like the minimum size of projects, you mentioned that it's different per project and you're looking at buildings 35 plus floors. But is there any information that you have around like age of buildings that might change the economics for a shorter building or a less tall building versus modern plumbing?
So for the most part, these buildings have similar infrastructure when it comes to their plumbing, so it wouldn't change from case to case too drastically. Older buildings might have more difficult infrastructure to enter, but no, for these smaller buildings, at the 35 floor range, it would have pretty similar installation, requirements to a 70 floor building. Because there's been very little progress in the form of PRVs in the past, 4 or 5 decades, an older versus newer building wouldn't pose, any different challenges per se.
Will you be procuring the micro hydro generator or building the prototype yourself?
So we plan, basically what we've done already is we've made connections with a bunch of different micro hydro generator manufacturers, which gives us the ability to procure based on the project need. That being said, we do hope on the side to be investing in research and development so that in the near future, we can produce our own micro hydro generator that is perfect for this use case.
I see. So where is your expertise in understanding which kind of buildings need what kind of micro generator specs? Is that the expertise of this team?
That in addition to like the expertise of knowing how this in-pipe hydro generation has been used in different use cases and how to take that and use it in this use case.
Okay, thanks.
Thank you so much, Electromame.
Thank you.
If Self-Res Power wants to start preparing, Joe, do you have a joke for us?
Sure. One I have is, what do you call a bad electrician? A shock absorber. That one's a little tough. I don't know about that. But why did the robot fail his exam? It was a bit rusty. Oh. Yeah, there we go. Let's see what else I've got here. What is a plug's favorite chant at a sporting event? Charge. All right, with that very awkward transition, we'll turn it over to Self-Res Power.
All right, Self-Res Power, your 10 minutes starts now.
Okay, thank you. So hello everyone, this is Ray Yang from Self-Res Power, and today let me introduce you the future of electric vehicle charging using our super compact wireless charging infrastructure. As we all know that electric vehicles have drawn worldwide attention as a potential successor to gasoline vehicles without air pollution, and ambitious EV penetration plans have been announced by the governments around the world for the purpose of the environmental protection, carbon emission reduction, and also for the industrial upgrade. Accordingly, the global EV sales is projected to increase 37% annually and reaches 1 billion units in year 2050. And despite of the rapid development of EVs, there are still certain application issues with the current conductive charging. By comparison, the innovative wireless charging shown on the right allows EV to be charged without physical cable connection in a safe and robust way. No operation is needed during the charging process, so the driver will be free from any electrical potential shock. No cable is required, so the maintenance will be easy, and the charging system is in fact buried underground to save the space. And by dynamically charging the EV on the highway, the battery size also can be largely reduced. And the concept of wireless charging is quite simple. When the car is parked, as shown in the figure on the top left, the power will be transferred wirelessly from the ground pad buried underground to the power pad installed beneath the car chassis. Though this is an emerging market, its size will continue to expand from $16 million in 2020 to over 200 million in 2027, with nearly 50% annual growth rate. And the market survey indicates a high interest for wireless charging from potential EV customers. In fact, customers are more willing to consider EV instead of gasoline vehicles when wireless charging is available. And there are a few number of leading companies in the wireless EV charging industry with different market focus, including passenger vehicles, public transit, public charge station, and the individual customers. And in spite of different product specifications, there are several common limitations in the current products, including as shown here on the left, low system efficiency, large size, and high cost. And that is why lightweight wireless charging systems with low cost are strongly needed in the current market. And by using our proposed charging pad infrastructure, we can solve all the challenges here and have the opportunities to reshape the future EV charging market. In addition to accelerate the EV adoption rate, Self-Res Power also gives rise to several potential social impacts and creates a pathway to a better future, including carbon emission reduction, support for disabled drivers with autonomous charging, and also help automotive industry workers whose jobs are lost due to the energy transition. And here is a quick intro on our technology. Our unique charging pad structure is shown on the left, which is made of multiple layers of cover trees and dielectric material. By this enabling self-resonant concept, our wireless charging pad is low cost, lightweight, with compact structure. And you can see from the figure on the right that compared with other current products, our wireless charging pads can achieve 10 times ultra-high power density. And this structure can be adopted not just for EVs, but also for buildings, consumer electronics, robotics, and medical applications. And starting from 2015, our team has been continuing to improve our concept. We have published multiple journal papers to validate our concept with 2 patents filed. In 2021, we delivered the first high-power prototype, and just earlier this year, we finished the design for manufacturing tests. And right now, we already have 1 ongoing project with Magna, 1 Fortune 500 company, and we have one proposal pending with Volkswagen. And by the end of this year, we will begin the auxiliary design for the product and begin a test on actual vehicle. After that, we will begin to expand our customer base, mainly including major automobile manufacturers such as Tesla and Volkswagen, as well as the Fortune 500 industrial companies, and also leading wireless charging companies like Electricity and Hyvo. And note that here, for the current wireless charging companies, they have been in the industry for about a decade, and they are still looking for new technologies for the next generation of wireless chargers to solve the limited power density and high cost. And our technology will be licensed to them, which has much better performance in terms of size and cost. Their expertise in wireless charging, especially on the wireless charging regulations, will be beneficial for the partnership. And to give you a more clear understanding of our technical strengths, here I gave 2 pie charts of the cost and weight of the benchmark product in the industry. And the updated items in the pie charts represents the cost and the weight reduction contributed by our self-resistant charging pad. And the table below compares our cost and weight in blue with the benchmark product in red. And with our technology, we can in fact reduce most of the cost and weight on ferrite materials and resin capacitors, leading to a more than 60% reduction in total cost and weight. I know that this is in fact a conservative estimation. For future mass production, the cost and weight will continue to decrease. And based on the market survey result and the product cost breakdown, the sales forecast is shown on the top left table to estimate the revenue we expect to generate for the next 5 years. This forecast starts with a relatively conservative wireless charging penetration rate this year at only 0.05% share of the total 4 million EV unit market size. And a 47% annual growth rate is assumed for the wireless EV charging market, and the unit price for our wireless charger is set at $1,500, which gives significant advantage over the current 6,000 to even 10,000 market price. Of the complete wireless charging market, the annual units sold by self-res power is projected to increase from 20 units this year to around 2,000 units in 2026, with a 60% annual growth rate. And note that, as shown in the table bottom left, there are $83,000 startup costs needed in 2022 to get the product off the ground, mainly including the funds for the prototype testing, initial patent application, and marketing. And the income statement on the right shows all the revenue and expenses over the next 5 years. In 2022, self-res power is expected to complete the product testing and finalize product specifications. In 2024 to 2025, operation expenses will continue to increase to bring in more talented people for the system integration and mass production. Throughout the next 5 years, $35,000 is needed for patent applications, which are the key properties of self-res power. Positive cash flow is expected by the year 2025. And of course, to evaluate the risk of the business, 3 different cases, including low, medium, and high, are projected based in the break-even analysis based on different annual sales growth rate. The major contributors to the expenses including patent applications and new hires. The median case is a conservative estimation, which will have positive cash flow in 2025 and around 0.8 million profit in 2026. The high case is possible if we can maintain our technical strengths in the market for the lightweight charger solutions. The low case is also possible, but unlikely to happen, considering both our technical strengths in the market and the high developing speed of the wireless charging market. So in other words, we are confident about our chance to succeed and meet the milestone targets shown on the right, with 2,000 annual units sold and 3.6 million revenue by the year 2026. That is our story. Thank you. And my colleague Jerry and I will answer any questions that you may have.
Thank you so much for your presentation. I was surprised by how low the costs are for your first stage, and you've already done so much work. I'm assuming that the cost of staff, facilities, etc., is that being borne by the university, or is that being borne by the company?
It was borne by the, mainly including my research projects inside the university for the past 5 or 4 years.
Okay. Do you have an estimate of how much all of this would cost as a, instead of 83,000 for the next year, how much it would cost as a freestanding company?
Like a standing company, like I would say, like we need about to double that number because that initial cost does not include the expenses to hire more talents for the system integration. So if we want to like build like the complete company and deliver the final complete commercial product in the next 1 or 2 years to the companies, to other companies, like we need to double that initial cost. But for this year, I think 83,000 is enough to build a prototype to deliver to the initial customer.
Okay.
I might have missed this, but when you showed the landscape slide with companies like Plugless and Hevo, do you view those as competitors or customers?
Yeah, that's a good question. Like I start with review them as competitors, but the common thing for all those companies that they are going that, in our technology terms, like low frequency solutions, and that's why their solutions in the past 10 years are always comes with a high cost and a heavy weight. And now we have this like cell run structure at a high frequency. The size will be shrink with low cost for the prototype, and that's why it now gives us an advantage when consider them as competitors, and then give us another idea that maybe we can license our technology and work with them together and utilize especially on their technique, special experience in the regulations and the stuff.
Yeah, that makes sense. And then, so from a go-to-market standpoint, what are you targeting first as customers, like Volkswagen? Like, what's the category and how are you getting to those customers in the beginning?
Yeah, like as I said, for our technology, in fact, it can be applied not just for EVs, but for medical, cell phones, other applications. And we chose to start with EV markets first, that our technology is suitable for the high power application as prototype right now, although we have potential for other markets. And the second, we have one initial project with Volkswagen and Mellon right now, which is in the area of EV application. So we want to continue that trend first, and maybe several years later, we can go to other markets.
Great.
So to my understanding, oh, go ahead.
Okay, thanks. So the question is, it seems like this charger is useful for something as small as a cell phone as well as EV. So as how is the sizing the technology which is working for cell phone, the sizing increases for EV, and are there not any implications in terms of that kind of scaling with the same design choices?
Yeah, like I would say that it's like from our technology side that we use the same cell run structure that can be scalable to smaller size for cell phone charging or large coil size for EV charging. But although they may have different applications areas, but the same thing is our technology strength in its unique cell run structure. And I think additional information for you is that this EV market for their various charging is an emerging market right now. And we don't see like much competitors right now. But for the consumer applications of various charging, there are already like multiple companies working in this area. And they have some relatively mature solution right now. So that's why we want to start with EV.
Okay, thanks.
So to my understanding, like wireless charging for electric vehicles require like an additional charger or parts to be integrated into the actual vehicle itself. And as a result, increase the vehicle cost. So my question is, like in general, how do you see that perhaps being a barrier to consumer adoption?
Yeah, like that. But in fact, that's a key consideration for all those automakers like Tesla or Volkswagen. They want to make sure the additional equipment beneath the chassis of vehicle to be as small, as lightweight as possible. And that gives us a huge advantage compared to the conventional solutions. So like you can say that, of course, we need to add like additional like components under the vehicle for the vehicle charging, but it's also our opportunities comparing with other competitors in the vehicle charging market.
Gotcha. I think it would be interesting to see what the total cost of ownership for a wireless EV charging vehicle would be versus the total cost of ownership versus a normal plug and go EV.
Yeah, like I would say like I don't have like the number right now, but I would say like it's all driven by the customer needs and the trend of the future market for this EV.
Gotcha. Thank you.
Yeah.
Thank you so much, Solar as Power.
Thank you.
Lignalix wants to prepare. We'll start sharing your slide deck.
So as we come on, we'll turn it over in just a moment, but one joke I have is a sweater I bought was picking up static electricity. So I returned it to the store and they gave me another one free of charge.
I'm sure everyone is laughing at these jokes. I wanted to keep my mic on so you could hear some laughter this time, Joe. All right, Robert, are you ready to go?
All set.
All right, your 10 minutes starts now.
Cool. So I'm Robert O'Day. I'm the CTO of Lignalix. And at Lignalix, we're upcycling lignin to specialty chemicals. So you can think of lignin as sort of the glue that holds plants together. So on average, it's somewhere around 15 to 25 weight% of, for example, a tree. And it's separated out when, for example, a paper company at a pulp mill separates out cellulose pulp to go into, paper products and stuff like that. So there's about 100 million tons of this stuff generated annually. And, almost all of it's just kind of burned for heat. And as you can see from that picture, that's because it's really dark in color. It often smells quite bad. It's got kind of limited chemical functionality, so you can't really do much to derivatize it. It's just really kind of hard to work with. But it does have some really appealing sort of inherent properties to it. It's a really strong antimicrobial. It's a potent antioxidant. It's also a really strong UV absorber. And so, with all of these features and all of this stuff lying around as waste, this is really a huge opportunity. But lignin itself is just so hard to work with. And at Lignalix, we've developed this patent pending process to actually break down lignin to its chemical building blocks. And so previously this had to be done in really high pressure reactors, was really hard to scale up, could be somewhat dangerous. And we've sort of got this down to where we can do it in glassware. So key advantages of our process are it's just safer, simpler, more efficient than any existing way to break down lignin. And so it also has a lot of commercial and commercial potential as well as an energy impact. So this is really easy to just sort of bolt on to existing pulping infrastructure. Also really generates these platform chemicals and materials that we can use in a variety of applications downstream. As far as energy impact, this technology really enables scalable lignin first biorefining. So lignin first biorefining basically means prioritizing upgrading the lignin stream rather than, for example, pulping where we're focused on the cellulose to make paper. And so, this also kind of diverts a lot of that lignin that's just being burned from incineration, which reduces the greenhouse gas emissions associated with that. As well, if you're making something like a biofuel, for example, cellulosic ethanol, by actually upgrading, a quarter of your input stream, you can really make that more cost competitive with conventional, petrochemical fuel sources. So our go-to-market strategy is to partner with these upstream waste producers like pulp mills, take their lignin, run it through our process to break it down, and then very broadly turn it into high-value, low-volume specialty chemicals. And so the reason we want to do that is to be able to, really get this off the ground as a small startup. We need to have that, ability to sort of start generating revenue, so we can start scaling this process, and then we can go toward those larger volume markets in the future. As our beachhead market, where we've actually gotten some traction, we're looking at natural preservatives. And you can see here on the right some of our products. And sort of the reason we're looking at natural preservatives is, as I mentioned, lignin has some of those really appealing features, and then it's an antioxidant and an antimicrobial. So that's exactly what you want in some of these preservatives. And on the left, there's sort of a powdered form. On the right, there's an oil, and we can sell that to our customers in the personal care space that they can use to then, formulate different types of products with our two different product types. So kind of the broader opportunity here is in, a consumer-driven trend towards clean beauty. That's kind of broadly defined as, products with no ingredients that have known or suspected health impacts, products with fewer and more recognizable ingredients on the label, as well as things that are just, generally more sustainable. So less packaging, stuff like that. And, national brands and retailers are really sort of getting behind this push with, dropping new product lines as well as marketing pushes. And so, this is kind of a really big market. It's
specifically in the cosmetics preservative space, we're looking at our target market's about $1 billion annually. What's really exciting about this sort of clean beauty opportunity here is that the compound annual growth rate of this market's about 12%, which is really exciting. And additionally, kind of our product sits at this nexus between what end consumers actually want, which is these safe natural preservatives, alternatives to parabens, for example, and then what these product manufacturers actually need, which is sort of a cost competitive ingredient that can replace their current offerings. And so one of the main problems with natural preservatives is that you can use really exotic, expensive ingredients to sort of meet these consumer demands, but that's really hard to scale, and it's also just prohibitively expensive in a lot of cases. So additionally, especially in Europe, there's a lot of regulatory pressure to sort of phase out some of these less well-perceived preservatives and other ingredients. And so that's sort of a nice plus on top of what consumers and brands are already looking to do. As far as how we stack up against the competition, so our products are natural. They're sourced from a sustainable and scalable feedstock, unlike some of those exotic plant extracts. And they're also multifunctional in that they have that lignin UV stability, antioxidant capacity, and antimicrobial effects. They're also clean label friendly, which is what a lot of brands are looking for. They're easy to formulate, sort of across this broad range of pHs, as well as we have those 2 ingredient types that can formulate into different types of products. And most importantly, they're cost competitive. So traditional petrochemical ingredients can be a few dollars a kg, but right now what they're looking at in terms of natural plant extracts and stuff like that can be anywhere from $35 to well over $100 a kg. So by sitting at around 30, we're sort of hitting that happy middle ground between providing this natural product while also sort of getting a little closer to the conventional petrochemical end. So our long-term strategy is to sort of expand our feedstocks and products. So more of like a biorefinery type model in terms of bringing in waste like food, agricultural residues, breaking those down, and then sort of having 2 sort of tiers of product streams. One that's more refined, so those personal care ingredients like I've been talking about, as well as adhesives and other polymers, all the way down to things like wood glues and plastic additives. As far as traction goes, we started in 2019 where we did the local I-Core Sites program at UD. Since then, we did the national program where we've conducted well over 150 customer interviews. Since that, we've been sort of developing partnerships, providing samples to potential customers, doing some performance testing, as well as taking part in the Venture Well E-Teams program. More recently, we got a $2.5 million grant from the Department of Energy that pairs us up with NREL and Dynamic Extractions to work on some scalable separations technologies as well as technology maturation. To date, we've had about $3 million in non-dilutive funding. Last year, we're really excited. We had about $40,000 in revenue, and that's projected to increase to about $100,000 this year. So the team, Eric's our CEO. So he has a PhD in chemistry from CMU. I'm Robert, I'm the CTO. I'm in my 5th year of a PhD in chemical engineering at the University of Delaware. Christina is our COO. She's the Assistant Director of Innovation at Princeton University, as well as an I-Core instructor. And Professor Thomas Epps is our Chief Scientific Officer. And he has, quite a bit of experience in, lignin upgrading, especially in the field of sustainable materials. So with that, I'd be happy to take any questions.
Is Dynamic Extractions a CRO, or do you have a relationship with an existing CRO?
Sorry, can you say that again? I cut out a little bit.
Is Dynamic Extractions a CRO, or do you have an existing relationship with a CRO, a contract research organization?
Yeah, so Dynamic Extractions actually manufactures what's called CCC, so countercurrent chromatography hardware. So we're actually partnering them on sort of this development project to make that a little more scalable and applicable to the biorefining space. Right now, that's something that's used pretty heavily in, for example, pharmaceuticals.
And how are you doing manufacturing right now? Do you have a relationship with a contract manufacturer, or what scale are you at?
So we're at a relatively small scale in terms of providing samples, but we're working on a joint development agreement with one of our customers that would also, come with some terms around how we can start looking at contract manufacturing to actually scale up.
You mentioned the competition being a number of other products like paraben and hops extract. I'm curious about how the lignin oil kind of compares. Do you find it to be a 1-to-1, or the ratios are significant depending on what you're comparing against?
Depends what you're comparing against. So common conventional preservatives that are used right now would be like parabens and phenoxyethanol or benzoic acid. Each of those sort of has a different, different performance parameters and specific, especially in like the antimicrobial space, specific bacteria that they're effective against. So it sort of varies, but generally speaking, I'd say it's fairly close to a 1-to-1 in terms of most of the performance parameters.
Going back to sort of your unit economics side, I think you said the cost of lignin oil from you guys would be about $30 per kilogram. How does that compare with traditional petroleum-based parabens?
Yeah, so parabens are somewhere on the order of like $1 to $3 a kilogram. But sort of our value proposition here is that we're also multifunctional and that it's, got that antimicrobial and antioxidant capacity. So this can actually sort of replace more than one ingredient, which makes it a lot more competitive.
Gotcha. And I'm guessing that $30 per kilogram is like a projected cost at scale. So my question would be like, what are your main cost drivers and how do you plan on bringing them down over time?
Yeah, so thankfully, lignin's already kind of a waste stream. So it's fairly cheap. So looking around $200 to $300 a ton. So our biggest costs are actually going to be in, separations as well as recycling for solvent and other ingredients we'd use in a chemical plant. And so that's actually part of what that DOE grant is sort of tailored to, is, developing systems to really, make that scalable.
Great, thanks.
As we transition, I do have a Lincoln joke, I believe. Unless we have a couple more questions, I don't want to push too quickly. Okay, so here we go. So did you know, as far as this joke tells me, so Robert will have to tell me if I'm wrong, that the Lincoln content of old paper is what gives it an old book odor? It all makes sense now.
All right, thank you very much to the first 7 teams. We are now going to take a 30-minute break. We will be starting again at 1:30 with Alpha Nur. Please also consider signing up for our networking activity, which is tomorrow at 3:30 p.m. Eastern. You can find information on our website or use the QR code that is currently on your screen. Advisors from our 2 American Made Challenge showcases will be there, as well as experts from industry and investors. All of the competitors for EnergyTech UP finals and all the American Made Solar Prize Challenge competitors are also invited. So we're really hoping for it to be a wonderful networking event, and we hope all of you can attend. So please sign up during the break, and we will see you back at 1:30.
Good afternoon, everyone. We're about to get started again. It's 1:30 Eastern. So we're about to get started. I wanted to be just like Joe and tell you one joke, which is, what do wind turbines think of renewable energy? They're big fans. And with that, I'm going to pass it over to Alpha Nur.
Do we have control? Yep. Are you sure?
Ready when you are.
Thank you for that warm introduction, Anna. I'm Kevin O'Sullivan.
And I'm Mason Rodriguez-Brandt.
And we are Alpha Noor. Many remote operations, like military bases, are constrained by the availability of electrical power. Near populous areas, you can simply plug into the existing grid. But in remote areas, or when that grid is compromised, doing so becomes less trivial. The problem being faced by these remote operations using solutions like diesel generators and solar battery systems is threefold. Complex fuel supply chains makes ensuring continued power supply logistically challenging and subject to cost uncertainty. Secondly, existing solutions are inconsistent, causing huge inefficiencies when the power supply doesn't meet the power demanded by the operation. And thirdly, existing solutions are unreliable, riddled with power blackouts which cease operations altogether. All nuclear power accidents have been caused at some level by steam pressure buildup. We are leveraging proven advanced fission using steamless heat pipe transfer coupled with Stirling engines, which in tandem decrease fission safety radius from 10 miles to just 400 feet and keeps our systems walk away safe. Our solution is power dense enough for years of operation without refueling. Our solution is consistent enough to handle all baseload power needs as the primary source of power. And our solution is reliable enough to operate continuously with zero downtime. Coordinating with Idaho National Laboratory for exclusive IP acquisition, we will implement this technology into very small modular nuclear reactors that cater to these remote operations' uniquely sized power needs. Here's something to give you a sense of scale for the size of our systems. With the designs we are identifying with INL, our systems can safely and reliably be moved anywhere to deliver consistent power for the entirety of its lease. We at Alpha Noor are ecstatic to deliver our amazing product. We are passionate about nuclear science, and we are passionate about pushing nuclear science to the frontiers of the energy market. Our technology affords flexibility of scale, so we will construct a fleet of our advanced fission systems and lease them out to our beachhead market of federal entities like the DoD, who are not only clamoring to reduce power failures, but who also have unique regulatory immunity that decreases our barriers to entry. The revenue that we generate from these easier, cheaper to fulfill contracts will allow us to begin the civilian licensing process and expand into other remote entities like mining operations and rural communities, communities like Hooper Bay and Ukqiavik, Alaska, and the over 180 other off-grid Alaskan communities who are subject to predatory energy pricing and power failure, leading to food spoilage and hospital equipment failure. Now, the market for energy is huge. Just in the US, our TAM is $1.2 trillion annually. For our initial market, we will target the Department of Defense's military bases within the US with a market value of $3.5 billion. Specifically, we will focus on Army bases, and we believe we can service 30% of them, making our sum $380 million annually. Fortunately, we have so many potential energy industries to expand into as our secondary market. Just as examples, the US energy market per year for hospitals is almost $8 billion. And for mining, it's almost $3 billion. As for microgrids, they're expected to reach a market size of $50 billion by 2026. So why target the military bases first? Well, military bases need reliable, on-site, 24/7 power. And the US government is incredibly interested in improving their energy resilience. In fact, the DoD has recently allocated $287 billion to its Energy Resilience and Conservation Investment Program. And just in 2020, it spent $821 million to fund 27 energy projects, $40 million of which was invested to build 3 modular nuclear reactors. To add to that, the US government has even explicitly mentioned that due to the critical energy needs of its military bases and off-grid remote sites, it is willing to pay a premium for reliable power. Now, let me introduce you to my brilliant co-founder, Mason, to go over our financial model.
Thank you, Kevin. Now for the numbers. Our business model is a leasing model with military bases for $3 million annually per reactor, with a variable cost of $1.35 million to build each reactor. We should break even after year 2, and we would have 15 reactors by the end of year 5. Now, there are 4 key pillars to our value proposition when it comes to our competitive landscape. Firstly, we are scalable and modular, meaning our reactor can be manufactured in an assembly line-like process, allowing for rapid production. This is a big deal. Most reactors since the 50s have been custom designed and built on an individual basis, often taking years to manufacture. Next, we are extremely mobile. Given the size of this reactor, they can be transported by most any means, whether that is by aircraft, boat, or land. As seen earlier, multiple of these reactors can even fit on the back of a semi-truck. Given our regulatory immunity and selling to the government as our beachhead market, our time to deployment, as well as our financial barriers to entry into the market, are also extremely low. And lastly, on safety, our small design allows for extremely minimal risk of failure, and our passive safety systems rely on the laws of physics to shut down and cool the reactor during abnormal conditions, meaning the worst that can happen in the case of failure is that we're not generating electricity. You can bust a pipe, but you can't break physics. So how do we get here? Here's what we do. First, we need to confirm the feasibility of our reactor design with the researchers and scientists at Idaho National Laboratory and Argonne National Laboratory. Next, we will leverage a government SBIR grants of up to $2 million to build our proof of concept in-house at Idaho National Lab. Finally, we will seek VC investment to build our first fleet of reactors and lease them. Now, in only a few months, we've made incredible progress. What we found is that the market for these reactors is large and growing, and the government interest in commercializing them is high. In this short time, we have already been accepted into Idaho National Laboratory's Technical Assistance Program, in which they are generously giving us the time of some of the best nuclear engineers and scientists in the world to help us choose an INL proprietary reactor design to license. We were also accepted into the UChicago Polsky I-Corps program, which we will leverage to actively pursue clients across the DoD, VA, and other government entities throughout the following months. Now, we know that of those that receive SBIR grants of up to $2 million, which we will need for a proof of concept, 70 to 80% of those companies go through I-Corps. And we believe these opportunities will help us both license and build our proof of concept. Now, for our initial round of funding, we're seeking $4 million, which will be used to pay us, our engineers, and help us build out our proof of concept and first fleet of 4 reactors. We are also seeking industry expertise within the DoD, NRC, and Idaho National Lab. As for the team that will do it, here's our team. My co-founder, Kevin, and I are 2 science students here at the University of Chicago with experience in the Department of Veterans Affairs and Argonne National Lab. We put this company together out of a passion for nuclear science and sustainable technologies. Augie is our senior nuclear engineer who's a student at UC and an incredible technical lead. Ravi Amin and Caleb Weiss are senior economics students here at UC, and together have experience both in building multiple tech startups through accelerators like Techstars Chicago and across the sustainable energy industry. Our advisors include Leigh Nelson, the CFO of the energy company SwitchSource, who's extremely well-versed in the energy industry and was even named to Forbes' 30 under 30 in 2018. Thomas Moore, who is a Downers Grove-based nuclear consultant with over 40 years of experience in the nuclear industry and 15 years as a senior licensed nuclear operator, is also on our team. Finally, we have Star Marcello, who's the Deputy Dean of the Booth School of Business here at the University of Chicago with over 20 years in mentoring startups. Together, we see a move away from fossil fuels, where fission must be a part of the solution if we are to successfully decarbonize. Our small advanced fission reactor will be crucial in demonstrating that these new reactors work and will help further open the US market for fission. Together, we are dedicated to bringing fission to the forefront. Thank you, and we'd love to take any questions.
Love this, love fission, deeply interested in what you're doing. My main question is around the materials sourcing. I don't think you touched on it. I think what's the quote from Back to the Future, right? Doc, you can't just go to the store and buy plutonium. So I'm really interested in sort of material sourcing and cost and how that affects the product that you're building at a small scale. And also you highlighted safety as a main benefit. And I'm super curious about how you're thinking about sort of the outputs as well.
Okay, so for sourcing of fuel, we have been in conversation with the National Nuclear Security Administration, and they're experts in trying to lower the amount of highly enriched uranium across the globe, and they really work to make sure that the sourcing of nuclear fuels is adequate and consistent with their proliferation goals, and ensures that our designs are non-proliferative and just consistent with the overall goals of national security. So they ensure that our supply chain is secure and that our supply chain is affording us a level of fuel that is not going to cause proliferative concern, and that supply chain is secure. As for safety, we are coordinating with consultants in the nuclear industry and national laboratories like Idaho National Laboratory and Argonne National Laboratory to ensure that our systems reach the highest standards of safety. And we're beginning conversations with the Nuclear Regulatory Commission now to ensure that the software handoff to ensure that these processes are consistent with best practices is maintained.
Well, what about the cost of the inputs? That's the big challenge with fission to date, has been that the cost of the inputs is too high.
Yes, so each reactor that you think of today, you think of those large hyperbolic towers for each system. That is not the case with advanced fission. So with those systems, those generation 1, generation 2 reactors, they costed billions of dollars to build because each one was custom. So for each site, you had to build a custom reactor essentially, and a custom energy transfer system, custom site, custom management. Everything was ad hoc, which is horribly cost ineffective. And so by making our product consistent across each system, our economies of scale allow us a huge reduction in the prices and the cost of operation relative to these generation 1, generation 2 reactor systems.
So sort of on that point, what are you projecting to be the levelized cost of energy of one of your reactors?
Yeah, so we're looking at around 1.35 million is what we're estimate per reactor. The levelized cost of energy is competitive with current sources, so it's going to be around. It could be in the range of $20 per megawatt hour up to 50. So we're trying to get that as low as possible, which is competitive. However, we don't have a great sense of where it'll be in that range, but it will be in that range depending on which reactor design we go with. And so we've looked at the various ones we've gotten from Idaho National Lab. And so it will depend on sort of measuring this up with safety, with able to source materials and these other considerations, but within a cost competitive range.
Great, thanks.
Thank you.
So you have mentioned that the design is going to be standardized and then economies of scale play out, but there was a reason always why, like your primary customer, for example, US Department of Energy, they asked for custom designs of the nuclear reactor to be just site specific, which fulfills the requirement. So if you're building like a cookie cutter solution, how do you justify that being adopted by your potential customers?
Yes, so the Nuclear Regulatory Commission has a twofold process. There's a site license and there's a reactor license. So anytime you get a reactor license from the Nuclear Regulatory Commission by itself and outside of the scope of a combined license, you can have the regulatory go ahead to build as many as you want. That reactor design is okay by the Nuclear Regulatory Commission. The site license is a different thing altogether. And you have to make sure that there's certain needs met in terms of hydrology. There's certain with plate tectonics that it's relatively inert and not a concern. There's a lot of things that go into making sure that site license meets the standards of the gold standards of Nuclear Regulatory Commission guidelines. We're seeking to get a mobile reactor license, which is a novel approach within the Nuclear Regulatory Commission. It would be a new process. But it's one that they're willing, with the people we've talked with, who have a high degree of relationship in the Nuclear Regulatory Commission, that it's one that they're willing to open a conversation about, and it's one that they're very interested in implementing.
In your slides, you shared that your timeline for first deployment is the beginning of 2024. That's less than 2 years from now. Thinking about the dependencies, where do you see your biggest bottleneck? And I heard you mention this novel nuclear licensing. Outside of, I guess, licensing, where do you see additional dependencies on you hitting your timeline versus being faster or slower?
Yes, thank you so much for the question. So to address that, the reason why we see ourselves able to do that in 2.5 years is because our first approach is to go with the government, specifically with these military bases, and even more specifically, forward operating bases. And so the government has come out with a lot of interest in this area. And it's particularly beneficial to us because we don't have to go through the normal Nuclear Regulatory Commission processes to go directly to the DoD military bases. We would, however, to go to these civilian sectors. And so this we see as our biggest hurdle. So our biggest hurdle is getting this license through the NRC to go into the civilian sector for the longer term. And that's why we're going directly to the government first, because we believe that, well, we know that they're not regulated by the NRC directly, and they're highly interested in getting these reactors deployed. And so if we have that immediately, then it'll give us the time to get the NRC license and be able to go into the civilian sector afterward. But that process is costly and long in time, which is why we first plan to go with the regulatory immunity process.
Thank you so much, Alfrener. That's your time.
Thank you.
Thank you guys so much for your time.
Mesophase, you're up.
As mesophase comes on, nuclear energy technology, often very radiating, but I heard a joke the other day about headaches. And if you have a really bad splitting headache, you could sometimes call it a nuclear headache. There we go.
All right, mesophase.
Hi,
Can you all hear
everyone.
us okay?
Yeah.
Yes, perfect. Your time starts now.
Hi, everyone. My name is Yajin, and my co-founder, Michael, is also on this call, call from Europe. We are a team based on MIT commercializing a highly efficient condenser for power generation. So nearly 1 billion people do not have access to electricity nowadays. On top of that, global energy demand is going to increase by half over the next 30 years. So the question is, how do we fulfill this increasing energy demand with the resources we have, while we also try to reduce the footprint and climate impact in energy production? So first, let's look at how energy is being produced. 3/4 of global electricity are generated by thermal power plants. This includes not only fossil fuel plants, but also renewables like nuclear and geothermal and solar thermal. Do you still hear me? Because it says I'm signed out. Okay, going forward, we are still relying on thermal power plants, and a portion of fossil fuel will be repurposing for next generation power, and there will be a larger trend in renewable as predicted. But we are not moving away from power plants, and instead we need more efficient way to generate power from power plants. So first, let's understand how power plants work. This is a very simple schematic of a power plant. Basically, a working fluid is heated up by a boiler or a reservoir in geothermal, and then generate power in the turbine, being cooled down in the condenser, and then pumped back to the hot side boiler. Efficiency of this cycle is determined by temperature difference between this hot side and the cold side. We could, in theory, increase the T hot or decrease the T cold to enhance efficiency. The reality is, it's very hard to increase T hot due to limitations in material or heat source temperature. On the other side, it's relatively easier to decrease this T cold by having a more efficient condenser. And that is what mesophase is trying to do. You may ask why this haven't happened in the past. So in reality, industrial condensers have not seen much innovation for decades. For now, the condensers still rely on these flat metal tubes as shown in this picture, because these flat metals are relatively cheap, scalable, and very robust. But they are not a great candidate for heat transfer. When water condenses on this flat metal, they will form a thick liquid film, as shown in the schematic. And this film is the dominant resistance to heat transfer and efficiency in a condenser. Mesophase aims to eliminate that thick liquid film by surface engineering based on an invention developed at MIT. So this surface has shown a quick removal of droplets in the format of drops as shown in these two videos. And this could enhance heat transfer. And also we demonstrate over 200 days experiments in a condition that is similar to power plant condenser. In fact, our surface has shown record high performance in terms of heat transfer as shown on the y-axis and also robustness, as shown on the x-axis. On the left side of this plot, you are seeing the state of the art in academia. So there are some coatings have shown great heat transfer, but they are not robust enough to be applied in industry. And on this bottom right corner is some advanced surfaces for condenser in industry. Most of them rely on fins or extended surfaces. They can last for long, but not as great as our surface in terms of heat transfer. Our surface has demonstrated over 7 times heat transfer for over 200 days of experiments. And we only modify the surface with low-cost material, so we only add less than 10% any manufacturing cost to your condenser. So what does that 7 times heat transfer that we demonstrated on our surface mean? It means we can boost up to 7% power plant output, which is worth $12 billion per year global market. It also means that we will be able to squeeze 500 terawatt-hour electricity out of existing power plants per year, which can provide basic electricity for 1 billion people without building any new power plants. And because we are generating power in a more environmental friendly manner, we can reduce 0.5 gigaton CO2 emission per year, which is equivalent to emission from 100 million vehicles.
So how do we realize this vision that Yajing has laid out? The short answer is tubes. The reality is the tube market today is largely commoditized, and it's the cheapest part of a condenser. Why we're attracted to tubes is the fact that we can get to market quickly and realize that benefit for our end customers, the power plant operators, at relatively low cost and relatively little complication. Tubes also enable us to protect our IP by involving us in the manufacturing process. To get to those customers, though, we know that we will need to partner with the organizations with which they already have strong relationships. So we're already talking to folks like Graham and Alfa Laval to build those partnerships and get in front of the end customers, the Calpines, Mosaics, et cetera, of the world. The market for steam condensation globally is a large market. There's already about $130 billion of installed base of steam condensers that turn over about once every 10 years. That said, we're not going after the 3.4 terawatt global steam production market. Instead, we intend to focus initially in the US and specifically on the application that best suits our technology, which is geothermal, because of the constraints on the heat side, unless we can increase the heat of the earth. That market is about $300 million a year. So the economics are relatively attractive for us relative to conventional condensers. A conventional condenser costs about $22,000 per megawatt to manufacture. And the manufacturers in this space operate with relatively compressed margins. The prices average about $30,000 a megawatt, although they can stretch up to $75,000 a megawatt in certain cases where there's higher willingness to pay. In contrast, our condensers would cost only about $24,000 a megawatt to manufacture, so a slight increase relative to what's out there today. But because we're generating a significant amount of value through the power output enhancement, thank you, we'll be able to share a great deal of that value with our end customer and also generate strong margins. So the 7% increase in power output equates to about $123,000 per megawatt in PV, of which we plan to share more than half with the power plant operator and also share a significant amount with our partner, the manufacturer, while still generating strong gross margins for us and the manufacturer. So why geothermal? As I mentioned, geothermal is the strongest use case for our technology, given the constraints on the heat side. So given those constraints, we can generate upwards of a 7% increase in power output in those plants. But maybe more importantly than that is the fact that geothermal plants tend to be small. So that enables us to go to market more quickly and more cost effectively than if we were to go into natural gas initially, for example. Finally, because geothermal is a growing and renewable power source, we'll be able to get into greenfield operations, which for folks that have operated in the power generation space, you'll know that getting into greenfield is quite a bit easier than trying to fit into the replacement cycle on a brownfield site. So ultimately, to summarize this, our goal is to go into geothermal first, pilot, learn quickly, generate a ton of data, and ultimately scale up to larger facilities. Through upwards of 25 customer interviews, we've heard consistently that there is a great deal of value to be had by increasing the condenser efficiency. So looking at the LADWP quote here, increased efficiency of condensers would be a game changer for them. If you can squeeze out even an extra 1% of output that you didn't have before, that's huge. Similarly, from Calpine, the largest owner and operator of geothermal plants in the US, it's a constant challenge to maintain steam and output of geothermal plants. They invest in incremental efficiencies, and they would be excited to explore a pilot. All this to say that if we had a product manufactured and ready to market today, we would already have customers.
We have spent the last 3 to 4 years to develop and demonstrate this lab scale prototype under fundings from DOE and APRI, and we believe now is the time to take this technology out of the lab, demonstrate the performance at a larger scale, and by 2025, we should partner with testing facilities to demonstrate the performance of 2 bundles, before which we can pilot in a real power plant in 2028. We are seeking funding for the early stage prototyping and team building, and the grants from EnergyTech could greatly help us with funding needs, and more importantly, connect us with DOE for continuous support on this effort to make mesophase condenser a game changer in the real world applications. We are a team combined with expertise in technology and business development. My name is Yajin, and I am a PhD in mechanical engineering department at MIT. Michael is an MBA at MIT Sloan. We are advised by a group of talented and supportive advisors as shown here, including my advisor, Professor Evelyn Wang.
Thanks so much, Mesophase. That's your time. We're going to move on to Q&A.
Thank you.
So I'll start off. Thanks for the great presentation. I think I want to understand the levelized cost of energy. You mentioned US is the market you are first going for, and it's geothermal. So given where the geothermal plant is located, the prices and at which they sell the energy to the grid vary. So have you done some empirical analysis into those costs?
So we have we know geothermal is located mostly in California, and we have talked to Calpine, which is the largest geothermal developer in the US. And we are not competing with geothermal power plants. That's why we are not comparing the price of the electricity, but instead we are trying to improve the economics of geothermal power plants by improving the power generation of the existing plants and any new build plants. And we have received interest from Calpine in potential pilot with us once we have a larger prototype.
No, this isn't your beachhead market, but how long do you think, if you were to retrofit this into a natural gas fired plant, for instance, how much downtime would that plant need to experience in order for you to switch out the condenser?
Yeah,
that's a great question.
Yes.
Oh, go ahead.
Okay, I'll take it. So from the conversations we've had with nat gas plant operators, our understanding is that we would try to fit into the regularly scheduled maintenance, so either within the 2 to 5 year cycles. In terms of retrofitting tubes, it's obviously pretty variable on the size of the plant, but given that those replacements are done during those cycles, I don't think it would be out of the norm for them to replace the tubes during those cycles.
Cool, thanks.
Question about the geothermal and sort of go-to-market approach there. How much, I get the benefit of having them be smaller facilities is easier to kind of get to them, which is great. What's the proxy for getting to those larger nat gas? Like, how is it similar enough that it's going to teach you enough during that process that you can get to them, or is it going to take a lot of different product development and tweaking?
Yeah, I can take this, and Yejing, feel free to add on. From what we've heard from both geothermal and Calpine is both geothermal and nat gas operators. So the impression we got from them is that actually starting in geothermal would give us a better prototype to take into nat gas, given challenges of operating a geothermal plant. You're working with a less clean material.
Yeah,
we should actually have a better robustness proxy to take into a nat gas plant in the future.
Yeah, one thing I would add is geothermal plant is usually 1 to 10 megawatts, and natural gas plant is like 100 to 1,000 megawatts. So it's like 10 to 100 times different, but they all utilize the same size of the tube diameter. It's just the length of the tube would be different. And some power plants will use modules, small modules of condensers. So it will just be multiplying the same unit we have been made for geothermal.
Can you talk a little bit more about how you plan to pilot? I know that there's a lot of new geothermal being thought about, but the complexity of just the general geothermal development process tends to have people focused in one area versus another area.
Yeah, sure. We talked to a few geothermal people, including people from DOE just yesterday. It seems that many geothermal are focusing on the drilling process. But once they figure out the drilling, then they will just outsource other parts of the power plants, including the condenser. And this is what we also learned from Quiz Energy. They are a startup very focused on the drilling, but at some point they will build their power plants. And that's when we can step in and provide them our enhanced condenser.
But to get, I guess, to add to that a little bit, the view of a commercial pilot would likely look like something like working with EPRI initially to test the technology in a kind of a lab scale pilot, and then take it to Calpine or someone like Calpine to put into just a flow part of the plant to expose it to plant conditions, and then ultimately scale to production.
Thank you so much, Mesophase. That's your time.
Thank you all.
Spar, if you could prep for your presentation. All right, Andrew.
Thank you. Hi, everyone. We are Andrew Choi and Jiamin Wang with the self-powered autonomous robot for power lines. Power lines frequently suffer from premature failure, and there's a dire need for a cost-effective, sustainable solution to protect critical assets, uphold public safety, and prevent economic loss. SPAR is designed to fill a gap in existing technology to relieve this pain point by combining vibration control of power lines with inspection and condition monitoring. Our customers are utilities and government agencies, and companies have already shown interest in partnering with us to develop and commercialize SPAR. SPAR will improve resilience and integrate with the smart grid, leading to increased reliability, job creation, and protection of national interests. Market assessment and technology identification. The energy sector was given a C- rating from the American Society of Civil Engineers in 2021, partly due to aging infrastructure. Some of the electric grid is over 100 years old, and 70% of transmission lines are over 30 years old. Problems are expected to accelerate due to climate change and additional demand from the move toward electric vehicles and other technologies. These growing pressures have led to increased innovation to modernize the grid. SPAR is our contribution to the modernization initiative and is designed for utilities who must abide by regulatory standards for reliability and who wish to mitigate the risk of adverse events. For the US market, these utilities are divided into 3 general customer segments: investor-owned, publicly owned, and cooperatives. We also see potential in selling a data analytics package to government agencies to inform policy decisions. SPAR responds to our customers' urgent need to protect, inspect, and monitor power lines. There are many potential hazards such as wind-induced vibrations, vegetation encroachment, and electrical faults. These can lead to serious consequences, including the 2003 blackout, where 50 million people lost power across North America. Another more recent example is a Camp Fire in California, which led to 85 civilian deaths and caused $16.5 billion in damages. Even a simple outage can cost a data center almost $9,000 per minute. Current solutions for power line management have severe limitations. Fixed vibration absorbers cannot adapt to shifting wind conditions. Manual inspection is labor-intensive and dangerous. Other line-mounted robots are designed to navigate across towers and around obstacles, which causes them to be bulky, expensive, and frequently require user intervention. Unmanned aerial vehicles suffer from restrictions regarding visual line of sight and lack obstacle avoidance for autonomy. Furthermore, none of these solutions offer real-time monitoring. Therefore, competitors can only provide rotating coverage, forcing utilities to make decisions based on limited information. SPAR combines and builds upon the capabilities of these subpar options. SPAR's lightweight makes it suitable for long-term mounting. Its mobility allows it to adapt to changes in wind conditions and conduct inspection. It is fully autonomous with no need for user input. It is cost-effective at a low price point for its functionality. And it provides real-time vibration control, inspection, and condition monitoring in a single package. These competitive advantages translate to more accurate and timely information. SPAR's proximity allows it to capture greater detail of not only the power lines, but also of the towers, hardware, and clearances. SPAR can provide regular updates on important cable parameters like temperature and sag to help utilities revise their operation strategies. And the data can extend to other uses, such as siting infrastructure based on environmental characteristics. We intend to acquire customers through multiple avenues. First, we will pursue industry introductions by leveraging our current connections. These include Virginia Tech's Technology Transfer Organization and professional relationships our principal investigator developed while working in the energy industry. We will also actively expand our network by performing direct outreach to potential customers and attending trade shows and energy conferences like CERAWeek. As SPAR's technology improves, this outreach will include product demonstrations. Economic feasibility analysis. The US has over 600,000 miles of transmission lines with another 5.5 million miles of distribution lines. The table shows representative costs normalized to a per mile basis. Construction of a mile of transmission line costs between $1 to $3 million, and inspection can cost between $800 and $5,000 depending on the method used. Burying lines underground has grown in popularity. However, this can cost nearly $4 million per mile, making approval difficult due to the associated rate increases. Our estimated cost of components at a scale of 1,000 units is $250 per unit, with a slightly higher final cost due to assembly. These estimates are based on quotes and industry knowledge. We're able to keep the cost low due to SPAR's unique design. Its positioning requires cheaper sensors, and SPAR has a relative simplicity from being designed for a single unit per span. With increasing economies of scale as we ramp up production, overall costs are expected to remain relatively level, even with design improvements and upgrades. We estimated our principal cost for the same scale of 1,000 units. Salaries form the largest portion of our expenses at $600,000. Sales and marketing are expected to cost $400,000. Production of SPAR will cost around $300,000, and we've budgeted $200,000 for miscellaneous expenses such as legal fees and accounting. This results in a total cost of $1.5 million to bring a pilot production run of 1,000 units to market. We aim to introduce SPAR at a price of $500 per unit. SPAR is intentionally priced low to promote adoption and secure contracted cash flows on our real-time monitoring and data dashboard, which will be priced at $50,000 annually for every 1,000 units. We expect we need to raise about $2.5 million to reach sustainable growth. This would fund our initial production, allow us to quickly scale our business, and give us flexibility to pivot our market strategy, such as toward a full service model. We anticipate multiple funding sources to reach this goal. SPAR is currently funded by a career award from the National Science Foundation, and we are pursuing a small business grant through the NSF as well. We are also exploring funding from the Advanced Research Projects Agency, the Federal Energy Management Program, and the Loan Programs Office. These funds will take us from a technology readiness level of 3 to at least 6. Equity financing will increase our speed to market by enabling us to expand our team and more quickly achieve a minimum viable product with a top technology readiness level of 9. We will also pursue licensing deals in select countries, and this will provide us with additional customer feedback while generating revenue to sustain the expansion of our business. Potential impact. SPAR will lead to tangible benefits beyond those provided to our customers. Our company will actively promote equity and inclusion in keeping with our lab's commitment to support underrepresented students and community college graduates in STEM. On a broader level, the development and production of SPAR will create jobs in manufacturing and engineering, which, while increased grid reliability, will alleviate uneven burdens on underserved populations. These include rural and poor communities that are particularly vulnerable during outages, since they commonly lack resources like generators and stocks of non-perishables, as well as poorer minority communities that suffer from more planned blackouts from which more affluent residents are mostly exempt. We envision SPAR as a key component of the foundation toward a more reliable energy future. The Infrastructure Investment and Jobs Act allocated $62 billion towards the electric grid. This has spawned the Building a Better Grid initiative to support transmission projects and grid upgrades. As we move forward, it is necessary to protect both existing assets and future investments to approach modernization with increased confidence. Additionally, SPAR will integrate with the smart grid to provide critical monitoring data, leading to greater grid resilience and ultimately greater reliability. Overall business plan. Currently, we're working on formation of our startup and a full-scale prototype of SPAR. We expect to begin testing and validation within 6 months and make improvements over the next year. Within 2 years, we aim to transition into a small business by proving out our technology and business model via the launch of a commercial version at a scale of 1,000 units, while also pursuing licensing opportunities. We anticipate sustainable growth at a scale of over 10,000 units within 3 years, during which time we will also be working on additional capabilities. This scale is equivalent to just 500 miles, which highlights SPAR's tremendous potential to expand and address this unmet need. We have a team of 4 working on SPAR's research and development. I am a master's student and Jiamin and Paul are PhD candidates. Our advisor, Dr. Barry, serves as principal investigator. He has 10 years of industry experience, previous startup experience, and access to an investor network for a seed round. We have applied for an international patent that we have high confidence will get approved due to SPAR's utility and novel design. Our team is working with Virginia Tech's Link License Launch Program for IP management, licensing, and partnerships. They will advise us on transition strategies and contract negotiations moving forward. We have access to research facilities, including an experimental test bench and wind tunnel. We will perform field testing with our industry partner, Preformed Line Products, who can also assist us with selling and distribution. Our advisor has contacts at Dominion Energy, Consumers Energy, and Hydro One that are providing key customer insights and who may be our alpha consumers. We are also considering licensing to Semurica Electric Company. We plan to expand our team to include financial and regulatory compliance officers and additional engineers. Our focus will be US utilities such as PG&E and North Carolina Electric Membership Corporation before expanding to international utilities like TenneT and Tokyo Electric. We seek to partner with the Office of Electricity and procure a voucher to access the Energy Systems Integration Facility for additional testing. We will work to secure regulatory approval with the Federal Energy Regulatory Commission, as well as state commissions. Thank you.
Awesome. This is a super interesting idea. How many miles of power line can one sensor cover?
So SPAR is designed for a single unit per span. Most spans that we're looking at are going to be the higher voltage transmission lines, which is going to be close to about 1,000 feet. So you would need roughly 5 units per mile.
Okay. And then calculating from that, like what would be the size of your total addressable market?
So the total addressable market would be basically all of the transmission lines that are overhead worldwide. This would easily be into the billions of dollars. In terms of the market that we wish to attain, we're actually looking at a much smaller scale. We're probably looking to be in maybe a few million miles of transmission lines overall.
Got it. Thanks.
So comparing this product with this one competitor you mentioned, autonomous drones. So it's single unit per power line span. One drone probably can cover a lot more, and it can also be used for transmission distribution. So why would utilities choose this product above those autonomous flying drone solutions, which can cover transmission, distribution, potentially more area? Why do you think, on this other hand, this?
Looks like you froze on my end. To address
the number of products for each line span. Did I make my question clear? Sorry.
Yeah. You cut out for a little bit, but I think I got the gist of it. So we do realize that having 5 SPAR units per mile ends up being more expensive than the drone cost of $800 per mile. But however, the drone can really only do that inspection on a rotating basis. So typically once every 1 or 2 years, and it also can't provide condition monitoring. So it can go in and it can inspect the things and it can actually send out, a report or those images. But what it can't do is give utility companies all of this additional information that they can use for dynamic line ratings and to give them real-time warnings of if we see corrosion on the line, if we see fatigue damage, if we see vegetation encroachment, all of that's in real time. And so if SPAR prevents even one adverse event, it'll create a return many times its original cost.
Have you thought about the implementation costs and installation costs of the system, plus the preventative maintenance and swapping out of parts that's going to have to happen because they're running on a continuous and autonomous basis?
Yeah, so even though they're running continuously, one of the things that's so great about Spar is that it's actually not moving all the time. So you can choose different operation schedules in terms of if you wanted to go across the span once a month or once every couple months or anything like that. So really the only replaceable part that is going to have to factor into this would be the wheels. And we estimate that at most that would be once per year. Otherwise, it's going to be completely sustainable for long duty cycles of a marginal lifespan of at least 5 years, and we're looking to get that closer to the 8 to 10 year range.
But would your team be the ones who are swapping those wheels out as an example, or would it be the customer?
So originally we were thinking about maybe doing a full service model, but the capital cost to get to that scale is much more difficult, which is why now we're leaning more towards licensing and direct sales. So instead we would have the customer actually put those on the line since they already have access to union line workers and such.
Cool, thanks.
And I know you're still in the prototype stage, but which kind of side of the utility are you seeking to sell to? Do you consider yourself a transmission product or purely an asset management product? And kind of like as an outlay of that question, how are you distributing the data after it's received, calculated, and measured?
Sure, I'll handle the first part and then I'll pass it off to Jimmy. So we see ourselves primarily for transmission infrastructure, especially the more expensive higher voltage lines. However, due to SPAR's lightweight, it can actually be used for some of the higher or thicker cable distribution lines as well, depending on if that's something that our customers would want versus if they want to keep it towards the more expensive transmission lines. Jimmy, do you want to handle the information part?
Yes. Hi, I'm Jimmy Wang from the SPAR team. So the robots will be equipped with wireless sensors. And we're considering using a wireless sensor like the ZigBee so that they can establish a new local network that contains hundreds of these nodes within kilometers of range. And these robots will then upload the data related to motion collected from motion sensors and also from the inspection equipment towards local substations that manages and analyzes the data. And the local substations will perform a strategic update for the robot cooperative controls, and then also upload consensus data to the cloud server for general and global monitoring.
Thank you so much. Your time has run out. Solar Shepherds, you are next.
Great. Hello, we are Solar Shepherds Incorporated, agrivoltaic solutions, and we're here to talk about the future of farming and solar. I'm Daniel, and this is the team. We are all graduate students in sustainable technology at Appalachian State University. We bring a combined background in international agricultural development, environmental science, solar energy, and computer science to the table. In addition to our passion for sustainability, we want to engage rural communities in the energy transition. Over the course of this presentation, you will hear from each of us, except our mascot. Current national energy transition goals require new solar installations of 1 terawatt by 2035. While the US energy grid needs to become more sustainable, we also need to find ways to incorporate renewable energy into rural economies. All across America, small farmers and rural landowners are struggling to adequately benefit from all their hard work. Climate change and degraded soil quality add to these agricultural challenges, often leaving selling generational land as their only option. Here's our solution. Agrivoltaics is a dual-use land management solution at the nexus of energy production and agriculture. Unlike a traditional solar farm, which desiccates the health of the soil, an agrivoltaic farm diverges from solar monocropping and creates a symbiotic relationship that revitalizes the soil and increases the efficiency of the solar panels. We are focusing on bringing this technology to small farms, which according to the USDA have an average size of 231 acres and comprise 88% of all US farms. This means that there are approximately 1.9 million farms for us to target with our 50-acre modular approach. Solar Shepherds specializes in agrivoltaic consulting and financing, designed to connect investors with farmers and rural landowners. Our solution empowers landowners to generate additional income through renewable energy production while allowing them to continue agricultural practices, producing solar energy while restoring soil quality with little initial investment. With our system lifetime operations and maintenance agreement, we build long-term working relationships with farmers and their communities to ensure production from solar and provide support to help maintain their property and agricultural tax bracket. Solar Shepherds is altering historically exploitative solar financing models into mutually beneficial systems for both rural landowners and solar developers. And here's Jacob with our value proposition.
Thanks, Dan. Through modular agrivoltaic installations, we help small farm owners increase the value and health of their land. Through agricultural integration, farmers can continue to grow crops and maintain their tax bracket with additional revenue from solar production. Our standard system size is 50 acres and can fit up to 5 megawatts of installed solar infrastructure. It would take 200,000 installations to reach the 1 terawatt of solar needed by 2035. Bringing farmers into the energy transition allows for more equitable wealth distribution from solar energy production and directly benefits rural landowners and communities while still providing attractive returns for investors. Including operations and maintenance services as part of the agrivoltaics contract ensures better system longevity and expanded options for cultivation and support throughout the lifetime of the system. Our business starts with financing socially responsible investments and available federal grants for these agrivoltaic installations. With these inputs, we then produce sustainable energy, agricultural products, renewable energy credits, and carbon offsets through soil restoration. As Solar Shepherds, we strive to bring a profitable, sustainable, and simple solution to all parties involved. We negotiate energy pricing with the utilities to ensure solar energy profitability. We engage socially responsible investors and apply for grants to secure money for capital costs. We use our in-house design tool to ensure land suitability, including proximity to existing power infrastructure. We offer assistance in building a custom agriculture plan for each farmer and incorporate this plan into the solar system design. We not only manage commissioning and solar construction, we also take charge of operations, maintenance, and decommissioning at the system end of life. Finally, we negotiate possible grazing contracts for the farmers to ensure quality and value. Next, Lainey will discuss our target customers.
Thanks, Jacob. Our target customers are small-scale farm owners with at least 50 acres viable for solar, who are looking to get more use out of their land. Whether this desire stems from struggling agricultural production or motivation for passive income, we will maximize the productivity of their land by improving the soil quality and increase profits by adding new revenue streams. With our in-house design tool, we can further hone in on potential sites with proximity to existing power infrastructure. Looking at our strengths, these points are what make our business stand out in what we do. Our service provides a framework for photovoltaics that can be sustainable and provide economic stimulation in rural populations. We diversify our farmers' sources of income, providing funds to those who need it most. Our in-house design tool allows for improved customer identification and efficiency of project implementation. Additionally, this new approach to solar development will be supported by farmers and sought after in rural communities. We also recognize our weaknesses in this market. With the majority of profits going to investor payback over the first 20 years, the farmer and company profits largely come after the project is paid off. Next, agricultural planning is time-intensive. Each farm is different. Another challenge may be that our startup model requires significant project funding and the payback period for that money occurs over 20 years. The opportunities here are the aspects of the market and big picture that we are poised to take advantage of. Our business design disrupts the exploitative solar financing model. We are providing long-term opportunities and increasing land value. The large quantity of federal and state grants funding rural energy projects works out great for us. Current and predicted legislation in support of increased renewable energy development can only help. Also, by partnering with engineering, procurement, and construction companies, we can expand the number of projects we take on with reduced legwork. The market threats we face are variable energy pricing and competition from large solar contractors. There is also a difficulty farming in new environments, especially with increased climate variability. Finally, possible changes in legislative support for clean energy and rural development could threaten our model if we rely too heavily on grants. Nikolai is now going to conclude with some financial details and our vision for the future.
All right, thank you, Lanny. Okay, moving on to our finances. Solar Shepherds coordinates contracts with energy providers to sell power for anywhere from 5 to 12 cents per kilowatt hour, depending on location. Then, socially responsible investors or loans pay for the solar system and its construction. Our next step is to institute a 15 to 20-year repayment plan with about 7% annual interest, which we have modeled and accounted for. Depending on local energy rates, at least $2.5 million of remaining profits will be shared between the farmers and Solar Shepherds. Farmers still receive all profits from agricultural goods produced, and at the end of the day, there's also potential to cash in on carbon storage credits and renewable energy credits. This graph here represents a typical 30-year system lifespan and shows how those profits are allocated. For the first 20 years, the majority of profits are allotted to paying back the initial investors. Where our model diverges from the typical system comes once the investors are paid back, and all future profits are shared between Solar Shepherds and the farmer. We take an additional operations and maintenance fee throughout the life of the system to ensure efficient energy production as well. All right, so solar financing isn't new. Farm loans aren't new. We're just finding a way to give small farm owners a retirement fund while revitalizing generational land and livelihoods. By nature, our business model allows us to build long-term relationships with farmers and strengthens rural communities through the energy transition. At the end of the day, business success looks like investors getting their money back with attractive returns justifying their investment, a more sustainable energy grid, and improved long-term soil quality for farmers. We also strive to provide aid for rural family farmers so that they can keep their land when they might otherwise not be able to. By making land more profitable through multiple functionalities and adding resilience to the grid, we can contribute to decentralizing energy production. Save the farm, save the planet, sustainable and fair solutions for the world's energy transition. Thank you.
Thank you very much. I find this really interesting how you're integrating the carbon credits plus the solar plus the agriculture. The question is around the typical value per acre on the PPA versus the typical, depending, I'm assuming it depends on what people are growing, but their revenue that they're currently making. And on a follow-up to that, whether a land lease plus kind of grazing contracts would achieve some of what you're doing as well.
Yeah, that's a great question. So to answer the second half of that first, we would look at land grazing contracts kind of in addition to any agriculture that they would develop. Grazing is a little more hands-off. You can even hire shepherds to come in and do that for you. And in terms of value per acre, so none of those financials modeled agricultural profits. That was all just made from solar. And any additional profits would be from crops underneath the solar panels, essentially. But the typical model that we had, I think, was $3,500 an acre per year on average, modeled over 30 years.
To continue a little bit on that note, though, one of the big challenges of getting solar on farms has been that it impedes machinery from getting through the rows, and in addition, it blocks the sunlight from getting to the crops, so it really eliminates the vast majority of crops, and it stops the height of crops because you can only grow things under, right? And so you're kind of really in a small pool of things that are eligible to do this without specifically swapping out unproductive land or something like that for solar. So you're not really going to get the huge gain of agricultural productivity that you might be getting if you were just producing. So how are you thinking about the types of things that are eligible for this and the type of land that's eligible for this?
Yeah, well, when we're looking at agricultural productivity, especially, I think that this was one of the points with our general plan where, you know, a lot of farming communities are losing farming land to solar projects, and there's a lot of resistance to that. And so through allowing farmers not only to benefit from the possibility of producing renewable energy, but also retaining that land as agricultural land, that can really provide a lot of benefits and, yeah, kind of help us through those issues. As far as also, in terms, that's where our consulting comes in for the agriculture part, because it will be an adjustment for the farmers in terms of how they're farming. So that's why we feel that that's one of the main purposes of our business, is to help them devise a plan where they can grow shade tolerant crops and do it in a different way. Also, we're using a 50-acre approach, so that's not going to be the whole farm. So they're going to still be able to continue practices on other parts of the farm. Our goal is to just bolster their profits with like taking part of their farm and doing agrivoltaics on it. Yeah, so a farmer's only going to grow what they want to grow. And so that all is a conversation and a process that we go through on an individual basis to address their needs and the things that they're interested in producing.
Yeah, the rackings and like the panels would also be adjusted depending on those crops.
Mm-hmm. Spacing and height is a big factor that helps contribute to crop gain and whatnot.
Cool, thanks.
Mm-hmm. Thank you.
So the healthy soil part, I'm trying to understand, how is your business helping the farmer with making soil healthy?
Yeah, so that comes through a couple of things in our farming advice and our agricultural business plan. First off, coming through sustainable farming methods, but then secondly, looking at the grazing contracts where we can bring livestock in to refertilize the soil, you know, eating the grasses and pooping out the nutrients for long-term health.
Yeah, we've also looked at like chicken tractors for having those, they're a better height to fit under panels. And in comparison with a lot of the grasses that are currently used on utility scale solar farms, using native grasses, you have a lot more root systems building underneath, which then does improve nutrient retention, water retention, stormwater runoff. So there's kind of like a combination, depending on what you're doing, we still want to have a way to be improving the soil.
Yeah, and that's
So
where
it sounds, go ahead.
I was just gonna say that's where our term solar monocropping kind of comes in. It's just typical utility solar farms are just rows of panels with grass that's typically mowed, and it doesn't benefit the soil quality at all. So by being more active in our management, it contributes to that.
Thank you so much, Solar Shepherds. That's your time.
Thank you.
All right, thank you all so much. Thank you.
Smart eye
So
floor.
I'm going to interject because I have an actual agrivoltaics focused joke for all of you. So why did the entrepreneur decide to go into the agrivoltaic business? They heard it was a growing industry.
All right, smart eye floor. Your 10 minutes start now.
Thank you very much. This is Smart Eye Floor. We make the most out of every step. Sorry, my laptop was kind of. Oh. Okay, so now we are in the middle of an energy transition from fossil fuels to clean energy, solar, wind, hydropower, geothermal. But how about the mechanical energy? How about the wasted mechanical energy that we have every day? We live 90% of our life inside a building, moving here and there, and we're wasting just this energy. Can we harvest this energy to add to our grid or power our devices? The problem is there is no technology in the market that can do this reliably. Forget about a current company. let me introduce to you our technology. It's called Piezoelectric Nano Generator. It's an energy harvester and sensor. As you can see, it's a flexible mechanical energy harvester. When you have a mechanical contact with our material, it converts the mechanical energy into electrical energy. So in this sense, it's an energy harvester. In the same time, when you have a mechanical contact, the material can feel the mechanical contact and give you an electrical signal as an output. That's why it's a sensor. So it's a one coin that two sides, energy harvesting and sensing in the same time. Our team is the only team commercializing this technology, abbreviated as TENG, from a company called Voltsun. Why this technology is unique. From one mechanical contact, we light up this much LED lamps just from one mechanical contact. This is more than 700 lamps, actually close to 1,000. This is producing a power of 10,000 watts per meter square from each mechanical contact. Just to put this in perspective, a solar panel would produce between 100 and 300 watts per meter square. This is producing 10,000 watts per meter square. And why is that? This technology, Piezoelectric Nano Generator, is harvesting the power of tribal electrification. It's a phenomenon that happens in nature where the layers of the air would have a friction with each other, producing lightning, the one that you see in the thunder. So the lightning has actually terawatts of power, but it's very difficult to harvest. In our case, we use the same phenomena to design our nanomaterials that will have slight friction with each other to produce this much power. What's out there in the market in terms of the core technology? On the right side, you see Piezoelectric generator, which is a ceramic hard devices producing low voltage, yet it's a $32.9 billion market. On the other hand, our Piezoelectric Nano Generator is new. We are commercializing it for the first time. It's flexible, robust, producing 10 times higher voltage output and a staggering 10,000 watt per meter square. This not only allows new products, but also allow new business models that were not possible before. We were starting and we don't know from where should we start. And there's so much potential and so much applications we could use. And we decided to go with the Smart Eye Floor. It's the only tiles that can harvest and sense your footsteps. How it works? Smart Eye Floor works as an underlayment, as an underlayment to your ground to harvest and sense the mechanical energy. Well, what's the benefits to the customers? First of all, from each footstep, we harvest 15 watts from each footstep. So we produce clean energy that otherwise it was wasted. Second, we sense this energy. We monitor traffic in businesses and offices. So now customers can monitor the movements and the traffic on the footsteps of their customers in different parts of the business so that they customize their business for the best outcome. It works also as a fall or injury detector. If somebody falls on the ground, your father, your grandfather, you will get a signal. It's a security tool. If somebody stepped into your building, you will know. And lastly, it's a surveillance technology, something like a camera. Instead, we have a much better privacy. Camera will detect the faces of the people and the identity. But for some buildings, this would not be the best solution. And for us, we just detect 2 foot on the ground. That's why it has a higher privacy than video surveillance. What will be the customers? Now you can imagine the customer segment would be massive. It's big box stores, retail stores, smart homes, smart buildings, adult foster care homes, government offices, commercial offices. But from where we start, which customer should we reach to out first? We started our customer reach as business to business. We started reaching businesses, demonstrating our technology and getting a response. And one of the first businesses we reached out to was Mitsubishi Electric, and the vice president of Mitsubishi Electric for Innovation was actually joining us today in the call. And once he saw our technology, he immediately saw the application for the Smart Eye Floor, and he actually inspired us to go down this path. Then we signed a non-disclosure agreement with another Fortune 500 company. We also got an international interest from Mecca. Mecca is a city in Saudi Arabia where 2 million visitors visit each year. And the problem of monitoring the crowd is always pushing and death each year because of the vast amount of people in smaller areas. And they wanted to find a solution where it could help them manage those crowds, and ours is on the list. Who is the competitors? There is not really real competitors for this technology. However, there are two companies only in this space. One company is called Bavagen Inc., which they are producing 5 watt for each footstep, but their platform is actually extremely thick and very high price and just suitable for small areas, not for houses, not for buildings. The second one is called Scanalytics, which produces 0 volt, 0 power. They generate no energy at all, but they do sensing of footsteps. Both are using Piezoelectric. The first company, Bavagen, they produce power, no sensing at all. The second company do sensing, no power at all. Ours produce 15 watt for each footstep and produce high level sensing data. So our cost analysis, the cost of the competitors is between 75 and 160 just because they are using Piezoelectric. For us, it's just $15. Based on our customer discovery, an acceptable price point for some of them is $100 per meter square. However, the $50 price point is more exciting for mass adoption. Our cost of production would obviously require R&D, equipment, hiring, rent, patent fees. We forecast $1,071,000. And our cash flow model based on the market size. So market size of the smart city is $404 billion market. If we talk about the market of just traditional flooring, how the people are making their floors at the moment, it's $409 billion market. We're creating a new market here for the smart flooring system that we forecast it will be around 800 million by 2025. By 2025, our cash flow models, we assume we will have a 10% market share, and it will actually be very sad if we did not achieve that because we are in the position to achieve it. We're generating 40 million by 2025. Our equity and inclusion, we generate an affordable and cleaning energy solution. This solution can also help elderly in foster care homes. We generate electricity to power IoT sensors, or can be added to your grid to save on the electric bill. We create new markets and new jobs. Our role in the energy transition, 3 things. We generate energy, we sense energy, and we save energy. We generate energy from each footstep, 15 watt. Add this, how many people living in the household per day, you can get an idea about how much energy you can save. Second, we sense this mechanical energy to provide valuable data for businesses for making decisions. And lastly, we save energy. 30% of the energy produced in the US is actually wasted because of the energy management. Buildings that have places where ventilation is working 24/7, heating is working 24/7, lighting working. So these systems, we can minimize this energy waste using our technology by the data we're getting about our customer traffic and which parts of the buildings are used in which times, and this will reduce the cost of the electric bill on buildings and save energy. Our success goals is a partnership with Mitsubishi Electric. We think it will be very valuable. We can reach to $10 million by 2025. If we can win a contract with Mecca, this would be a mega contract, and we would have small projects to do direct to customer by 2025. This will be our 10% market share. And this is our team, which combine the technical expertise and business expertise backed with our advisors. And finally, this is Smart Eye Floor. We harvest energy, we sense energy, and we save you energy, and we make the most out of every step. Thank you.
Thank you very much. Along with the smart floor, I'm realizing that there's a lot of use cases from the sensing that you talked about outside of just the electricity generation. How are you thinking about privacy and cybersecurity?
That's a great point.
Based on the behavior you're capturing.
Sure. So yeah, obviously the privacy in our case, we versus when I discuss this point, comparing ourselves versus a video surveillance or camera surveillance, which can identify the people's identity and can get information about the customer. For us, it's just 2 foot in the ground. So what we do, we will monitor the movements of the people inside the building so that the business can make an informed decision about reorganizing their space for best productivity. But we will take the ownership for the privacy for our customers. So the privacy is obviously an important point, but by the merits of the core technology that we have, we don't preach the privacy point like the way it's violated now by videos.
So intuitively, the solution makes like the most compelling business case with high traffic areas. So more so commercial and smart cities, and probably less so residential use cases. How do you sort of generally see that perhaps limiting the size of your total addressable market, and as a result, the scale of environmental impact that you could achieve?
I didn't understand the question. Can you repeat this again?
Yeah, just thinking in my head that the solution would probably make the most financial sense in high traffic areas, right? So like Mecca, like you were talking about, or commercial areas like retail stores, and it might make less sense in low traffic areas like residential homes. So how do you see that sort of limiting the size of your total addressable market, and as a result, the environmental impact that could be achieved?
Yes, I don't see this limiting at all. This is just 2 different market segments. The first segment, as you mentioned, with this so many people, then the energy generation aspect of our technology would be the one that would be predominant, because there's how many people, how many steps is generated per second. And if you talk about a smart home, 700, like if you have a 15 watt per step, per 1 step for each person inside the home. If you add this up for how many steps you take, it would make an economical sense that it will lower the cost of your electric bill by 5 to 10%. And so this will add an energy aspect, but also the energy sensing aspect is also important for businesses, that they don't really looking for an energy solution. They are looking just for analysis for their space. And the smart sensing would be valuable. So I think there is two different customer segments we're talking about here, the energy generation segment and the sensing segment.
The applications for this seem so broad, right? Like there's a lot of benefit in the applications here. And even in your pilot projects that you're targeting right now, there are distinctly different types of use cases and customer types, right? And so I'm curious, can you share a little bit more about what the plan is are you targeting one specific use case or one specific customer type initially, or are you going after a broader application?
That's a good point. We're planning in the first stage as a business to business. So when we started talking with Mitsubishi Electric, we didn't have the full prototype of the smart iFlow. We just showed them the small piece of our prototype and how it harvests energy by mechanical contact. And now we are producing this is the tiles that we are producing at the moment. It's we produce it now in larger scale, and we are in a stage at the moment that we can execute on a partnership with a larger company working on this area to get us having the market share early on. And we see in the next future that we would be able to do direct to customer projects where we can have homes, convert them into smart floor homes. So this is our vision at the moment.
So for creating the nanomaterials, the starting point, have you considered the supply chain material, like how it is being supplied, sustainability of the supply chain, and the cost implications?
Yes, great point. So when we were working on scaling up from the small piece to the full size tiles, the scaling up, obviously we have multiple supply chains. We were trying sourcing materials from all of them and testing them locally, and we identified the good sources for the supply of our materials at the moment. The obviously supply chain got affected by the last few months by COVID, but it's restored now. So we're now having what we can produce the amounts that we need as we scale up.
Thank you so much, Smart i4. We are now going to take a short break. We'll be back at 3 p.m. I encourage everyone to get up from your computer, stretch your legs. We will start no earlier than 3 p.m. All right, Natrion, we are going to start with your presentation. I'm just going to give everyone just a moment to settle in. Welcome back. All right, Alex, your 10 minutes starts now.
Great. Yeah. Hello, my name is Alex Koskov. I'm the co-founder and CEO of Natrion. And we're a battery startup based out of Illinois and upstate New York. And we're developing solid-state batteries for electric vehicles that are safer, higher performance, but most importantly, very scalable. So, second here. There we go. So, I mean, electric vehicles are the next thing in automotive. There are going to be at least 20 million EVs sold per year by 2030, and those are conservative estimates. And so these will have to be mass market viable electric vehicles. They're going to have to use batteries that are safer and better in the sense of faster charging, more driving range on a single charge than what we currently have. And such batteries exist. They're called solid-state batteries. So solid-state batteries are what's going to let us charge up in 15 minutes, get 300 miles on a single charge of driving range, get rid of range anxiety, and do all of that without having any of the fire safety risks that we've come to expect from electric vehicles. So solid-state batteries are great, but right now there's not a single solid-state battery technology that's being brought to the market that will actually be able to scale quickly enough to meet this enormous demand for EVs. And so this is exactly the problem that we set out to solve. So we developed a new solution. It's called the lithium solid ionic composite, or LiSiC. And what this is a solid-state electrolyte for converting existing lithium-ion batteries into solid-state batteries using existing production lines. So this is, we can work with the current battery cell manufacturers and with their current production lines, their current chemistries, and immediately in the near term, roll out solid-state batteries. And then this also serves as a platform technology for some very exciting next generation lithium battery technologies as well, things like silicon anode, lithium metal batteries, and so forth. So this is the solution for now and for 5-10 years down the line from now. And it's highly scalable and it'll be able to meet the great EV demand. So here's exactly how it works. So right now, battery production processes use a manufacturing or assembly technique called roll-to-roll, where in the last step, there's a component called the separator membrane that's basically sandwiched between the battery electrodes. And this separator membrane is what's soaked in liquid electrolyte currently. So what we do is we make a solid-state membrane that mimics those existing membranes that are used on current production lines in the sense of having the same flexibility, the same thickness, everything in the form factor we've tried to nail down to be as close as possible to the existing membranes. And that way we can integrate in the last step of the roll-to-roll process and very quickly produce these solid-state batteries. So we like to call our technology a Goldilocks solution when it comes to solid-state tech. So right now, solid-state innovation is pretty binary from the fundamental material level. So you have companies that either pursue pure ceramic materials or pure polymer materials. And ceramics, as the name implies, are very hard, brittle, sort of inorganic materials that are, you get really, really great performance out of them in a battery, but that's about it. Because they're not flexible, because they're brittle, because they have to be thick, you basically have to completely redesign the battery production process and the battery cell design around it. So companies like QuantumScape and Solid Power, though very prominent in the solid state space, they're going to take forever, and I mean, 6-7 years from now, to actually commercialize their technologies at any meaningful scale because they're going to have to build out all the manufacturing infrastructure themselves for their new batteries. Now, there are companies like Ionic Materials, Solid Energy, they're doing polymers. Polymers are very flexible, very durable. You can make them really thin, and they're great, but you just can't get the performance out of them to be viable. And so what we do is a composite solution that blends both ceramic and polymer. And that way we have the performance of a ceramic with the favorable manufacturer friendliness per se of a polymer. So that's kind of our best of both worlds approach that we take here. So thinking about kind of the impact we can have on EVs, we can improve the operating temperature range of EV batteries from -5 to 140 degrees to -55 to 500. And this essentially eliminates fire risk at the battery cell level. Then, because of the voltage stability of a solid state battery, we can operate batteries, push them to higher voltages, push that voltage envelope, and also the temperature, obviously, and extract more power out of the battery. And for some chemistries, this could be as much as a 50% difference in energy density, which translates to a 50% improvement in driving range. And then finally, right now, a Tesla Model S, 30% of its battery pack mass and volume is not actually battery cells. It's cooling and electronic systems just to keep the battery cells from cooking off. So if we have intrinsic battery cell safety, we can get rid of those cooling and electronic systems and reallocate that space back to more battery cells and actually improve unit economics at the battery pack level. So that's another plus. Now, at the lab scale, we're making this material cost us about $10 per square foot, with lab grade, lab scale materials. Now we've gotten bulk quotes for all kind of the precursors that go into LISIC from major suppliers. And based on the bulk quotes, we could bring this feedstock down to 37 cents per square foot, tap on that at 20% contract manufacturing cost and a 30% profit margin. We could sell this material for 58 cents per square foot. Now for a typical EV battery chemistry like NMC811, which is currently produced at about $73 per kilowatt hour, this would translate to just about or rather less than $2 in production cost increase on a per kilowatt hour basis. So nothing significant to the battery manufacturer, given the immense safety and performance value that we bring. And so kind of what this translates to the market is, an average 1 gigawatt hour plant is going to use about 250,000 square feet of this material. And so this will translate to about $140 million in revenue per gigawatt hour manufacturing capacity that we service. To put that number into perspective, the new Tesla Gigafactory that just opened in Berlin, Germany, is targeting about 100 gigawatt hours. So there's a huge market that we could pursue by servicing gigafactories. As far as some commercial traction, we started qualifying this technology in EV battery chemistries in full-size cells with a number of major automakers. Renault was one of the first that we started working with. Hyundai more recently. IM3 New York is building what's going to be the third biggest gigafactory in the United States in upstate New York. So very pleased to be working with them. And then kind of next on deck, we're working with GM. 24M recently signed a supplier deal with Volkswagen. So that's very exciting. And then kind of looking pretty interested in the results that we get from these ongoing evaluations. We have a number of other companies, including guys like Rivian and Ford. So this is a real shark bite pain that we're solving for these automakers, and we've been able to attract this kind of attention from them for it. Now, kind of underpinning all of this commercial traction that we've got was actually defense traction at first. So before any of this happened, we started with Department of Defense Small Business Innovation Research, SBIR grants. Our first one was from the US Air Force for just $50,000. And that one we're converting into a phase 2 with the Army Special Operations Command to deploy LISIC-enabled batteries in a new surveillance drone called the Puma that you see pictured here. And more recently, we got a $200,000 grant from the US Navy, and we're working with Raytheon on that kind of work. So this is, the defense, it's not only non-dilutive capital that we can use, but it's also really great tech validation, often in applications that require even more from LISIC than the auto industry ever will. So if it's going to work for the military, it'll work for the automakers. And it also represents an early niche market that we can enter into on a smaller scale before going after automotive. As far as our tech roadmap, we're rapidly trying to take this up from a batch lab scale process to a high throughput scalable process that we can take and convert into a pilot production line. And so eventually, if we can achieve this in the next year or so, we can try to get LISIC and begin to build those contract manufacturer relationships and try to deploy LISIC and launch it in 2023. And we'd be targeting about 250 megawatt hours of manufacturing capacity when we start. Our team, I started this company with my co-founder, Tom. I'm a material science and engineering major at Illinois. Tom's a finance major in Indiana. And then Stefan on the business development side is a math major at Boston College. And we all know each other actually because we went to high school together. So we've been at it for a while. And then we've got a really great advisory board we put together, putting together over 100 years of experience in manufacturing, battery R&D, defense, technology development, and so forth. So kind of what we're hoping to get out of this is we're gearing up to raise a Series A closer towards the end of this year. And so we deploy any potential winnings from this competition towards continuing to build out our team in R&D and hopefully get more visibility to pursue DOE grants going forward, not just DOD, and also more visibility from investors for the Series A. But yeah, that's it. So thank you very much and looking forward to questions.
Hello, thank you so much for sharing about Natreon. It sounds like you have a really interesting combination of tech, and that's kind of combining a couple different technologies. How are you thinking about the forward kind of supply chain? I know you have a goal to bring down the costs. When you're looking, 5 years out, which seems like the time for commercial scaling, how have you guys been building around that or optimizing for that?
Yeah, thank you for the question. So, I think that's another way we try to separate ourselves from the other solid state developers is we've been very, very focused on unit economics from the beginning. So kind of how our R&D went was like, we said, here are the materials we're going to limit ourselves to using. If we can make a great electrolyte out of it, then great, we move forward. And if not, we'll have to figure something else out. And so what we did is, for example, on the polymer side, our major precursor is a material called polyvinyl difluoride, which is already used in battery production in the electrodes. It serves as the binder, the glue in the electrode. So economies of scale already established, bulk suppliers already out there and easy to access. And it's a similar thing on our ceramic component, the other piece of our composite. We actually use a material that's obviously we process it, but the raw precursor is already being used in cosmetics and the paper industry. So another material that'd be very easy for us to source. And that's how we've tried to defend ourselves even through COVID, through some of these things like supply chain issues, just focusing on materials like these. It'll continue, of course, that doesn't mean it's going to be an easy way forward. But for instance, we've already sourced a supplier for the ceramic phase working on the polymer side. And the process itself for making it is extrusion based so that we can go to the manufacturers already producing the separators for current batteries, and they can adopt this and start producing this for battery cell makers. So that's how we're going to try to accelerate our path to market and the scale up.
So do you sense or face any sort of kind of push from these like Ford or Tesla, whoever like you work with for licensing path instead of you manufacturing this and them buying it from you? Does it not become the case that they would prefer wanting to just license out the technology and on their end do the manufacturing given they have all the big plans already going? So
yeah, that's actually that's certainly so the tricky thing is that a lot of these automakers are very they have different strategies. Certainly licensing is a possibility with a lot of them. For example, ones that are very vertically integrated like Tesla and like to do all their own production, or for example, GM established a joint venture with LG Chem called Ultium Cells. And Ultium is just going to be a cell manufacturer for GM, and that's another potential licensing opportunity for us. But then there are others who are kind of other automakers, they don't have such close relationships with their cell manufacturers perhaps, and in those cases we'd most likely have to contract manufacture. But We're, as there is some time before we're really scaled up, we're just going to see how the industry continues to evolve and try to be as adaptable as possible.
Maybe for the sake of my own education and understanding the technology better, could you sort of explain how this sort of addresses some of the key pain points in EV adoption, such as affordability, driving range, and charging time?
Sure. Yeah. So right now, every battery out there in EVs, cell phones, so forth, these are these lithium batteries. And there's a charge transfer component in them. The thing that actually moves the lithium ions, the electrolyte, is always a liquid right now. And so solid state batteries, you replace that liquid with a solid material, as I said, ceramic or polymer, like we do a composite. Right now, the liquids they're the major bottleneck in performance, really. They're very unstable at high voltages and high temperatures. So you can't really pull all the performance that you can out of a battery cell right now with a liquid, because that's the limiting factor. So for example, a liquid electrolyte at best, you might be able to charge up, the really good ones, maybe in an hour, maybe in 30 minutes, but nowhere near kind of the 15-minute charge time that all these automakers are going after. Because you need really high current, really high voltage if you're going to charge that quickly, and the liquid just can't take it. And it's the same thing from durability. It's also the liquid over time degrades very quickly, so you're losing the capacity of the battery. Your car is going to keep running out of range, and yeah, so it's once you take the liquid out of the equation, it all becomes better.
Cool, super helpful, thanks.
Thank you so much, Alex. All right, next we have mechanochemical recycling of LCOs. All right, your 10 minutes starts now.
Hi, today we'll be presenting on the mechanical chemical recycling of lithium cobalt oxide batteries. Our team from Stanford includes Lina, myself, Evan, and Patrick, who couldn't be with us today due to a last-minute emergency. Before we get farther, we wanted to take a moment to thank our amazing advisors, Dave, Beatley, and Eric. Now, if our project sounds familiar, it's because Team 2 today discussed the same technology, but we hope that we can put our own special spin on it. With that, let's get started. Lithium-ion batteries, or LIBs, are revolutionizing energy storage across industries with their unprecedented energy density across volume and weight. As a result, we project an exponential growth of the LIB market, primarily driven by electric vehicles, but also consumer electronics and energy infrastructure, including storage for solar power. Cobalt scarcity is expected to choke hold LIB growth as demand exceeds supply. This limits LIB adoption because there are simply not enough materials to sustain currently projected levels of growth. In order to meet the dire need for materials, LIB recycling is a growing market that recovers metals from spent LIBs. Currently, only 5% of batteries are being recycled. So there's a ton of room for LIB recycling to parallel the growth of the LIB market. This represents the market opportunity that we aim to target. There's a particular large potential for lithium cobalt oxide batteries, or LCOs, which are a type of LIB. LCOs used to be the dominant LIB because of their use in consumer electronics, like my phone. But LCOs are now being phased out in favor of other LIBs that are EV and solar compatible. This transition period is the perfect time to work on LCO recycling to recover as much as possible. Our proposed technology is a mechanochemical recycling process for LCOs developed at the DOE's Ames laboratory. Professor Vitaly Pecharski from Ames is one of our advisors. Existing recycling methods recover materials from cathodes of end-of-life batteries in 5 steps. 1, initial physical processing. 2, mechanical processing. 3, chemical conversion. 4, separation. And 5, purification. Mechanochemical processing combines the first 3 steps into 1 step. It's quite simple. A steel ball mill is used to grind up raw batteries together with a metal such as aluminum. Ball mills are already found in existing plants as part of their longer processes. Later, magnets can be used to remove cobalt, and a separation and purification process yields lithium carbonate. Existing methods of recycling batteries have more steps than ours and have significant drawbacks. Pyrometallurgical methods, which are dominant in the US, involve burning or melting batteries. These methods don't recover lithium, only cobalt. In Asia, hydrometallurgical methods using strong acids or bases are utilized as well. Both existing methods are expensive, don't have amazing recovery rates, are environmentally suspect as they involve burning or harmful chemicals, and are just plain inefficient. For implementation, our three-part plan includes partner acquisition, tech implementation, and customer agreements. Let's dive into these, starting with phase 1, which is partner acquisition. Here, we aim to gain end-of-life battery feedstock to recycle. We focus on creating agreements with 2 groups of target partners, the first being waste facilities such as Recology, and the second being battery aggregator companies such as Call to Recycle. Phase 2 is tech implementation. To go to market quickly and avoid lengthy construction times, we acquire an existing recycling plant and retrofit it with our technology. Phase 3 is customer agreements. Here, we sell the recovered cobalt and lithium carbonate to raw metals customers, such as on the London Metal Exchange. Note that the majority of our revenue comes from cobalt, but we sell lithium as well, which, as previously mentioned, existing pyrometallurgical methods in the US don't even recover. The Argonne National Lab created EverBat, a comprehensive model to quantify lifecycle costs of batteries, including recycling. We used the recycling portion of this model, customizing it for the materials, equipment, labor, etc., required for mechanochemical processing, as opposed to pyrometallurgical or hydrometallurgical. We use many of the model's default parameters, including a 10-year plant lifetime, a $20 an hour labor rate, and a $2 per kilogram fee for obtaining LCOs. We project processing 3,000 metric tons of LCOs per year. This is a relatively small plant based on the available capacities of EverBat's ball mill options. We then model selling the recovered cobalt and lithium carbonate at market prices, which is a conservative estimate as cobalt prices will increase. Today, people pay $55,000 per metric ton of cobalt and $17,000 for lithium carbonate. Based on this, our financial projections for a single plant over its entire lifetime include $82 million in costs, $363 million in revenue, and $281 million in profits, or $28.1 million per year.
But we think that we can bump that number higher because major LIB consumers are willing to pay a green premium for recycled cobalt. And it's because of increasing regulatory and consumer pressure on large companies like Apple or Samsung to make their supply chain sustainable. And we make the greenest cobalt on the market. So the way it plays out is that these massive cell manufacturers apply downward supply chain pressure on their cathode and battery manufacturers like 3M or CATL to take our cobalt for the battery. And the big question is it feasible? And it turns out batteries are only around 2% of the actual cost to create your phone. So these companies have the financial wiggle room for greener materials. And considering the public image of sustainability that these companies have already crafted, we have both precedent and incentive to leverage. If we assume a 1.5x premium for recycled cobalt, it bumps our annual profits to $44 million, up from 28. And all this extra money gives us the financial breathing room for a pretty neat maneuver. A common problem in the LIB recycling industry is getting feedstock, basically making sure that you always have enough dead batteries to recycle. We want to bypass this problem by outbidding the competition. We'll pay aggregators extra to guarantee reliable feedstock. And for our financial models, we assumed we pay 25% extra. To vet this idea, we talked to a managing director at Call to Recycle, the largest aggregator of dead batteries nationwide, and he gave it a stamp of approval. One thing is this solution also encourages a positive environmental impact. The expansion of recycling collection programs, the subsequent increase in consumer recycling rates, and the decrease in landfill waste. And speaking of environmental impacts, our business plan actually includes one more. We can sell lithium cheaply to companies like Tesla and support the EV and energy storage industries. Now, we want to be realistic here. We're a profit-driven business. But the reason we can do this is because current recycling methods don't even recover any lithium from LIBs. We do. So our revenue margins would be better than our competitors, even if we sell lithium at a discount, and we can play a role in supporting the green transportation transition. The big numbers. The baseline annual plant profit is 28 million. A green premium on selling cobalt brings profits up to 44 million. Paying extra for feedstock and selling lithium at half the market price gives us a final annual profit of 40 million per plant. Our technology allows us to manifest significant profits over the competition while still supporting green industries. Let's do a quick recap of impacts. 1, we'll charge large LIB consumers a green premium for cobalt, having the impact of decarbonizing their supply chains. 2, We outbid our competition for reliable feedstock flow, having the impact of supporting consumer-facing recycling programs and preventing LIB waste. 3, we'll sell lithium cheaply to support the EV transition and help decarbonize the transportation sector. Now, moving forward, we're targeting a huge market. The global market for LIB recycling will reach 11 billion in just 5 years. A tenth of that is LCOs, making our SAM 1 billion, and we estimate a SOM of 280 million, equivalent to 7 to 10 of our small plants. So what puts us above the competition in winning this market? The short answer is it's driven by the patent technology we're pitching and the structure of our business plan. We have a secure feedstock flow, avoid toxic processing, support local economies, incentivize consumer recycling, and recover lithium. No other competitor has the same combination of traits. We propose an ambitious but feasible launch timeline for this. We'll raise late 2022 for our pilot. And in terms of startup costs using the Everbat model, the total capital investment estimate is 3.7 million. We'll launch a pilot in 23, beginning in California, scale our pilot to other states by 26, and spread nationally by 30. Each of our plants will be cash flow positive within a year of operations. Now, we define initial success as successfully operating at least one plant, which is reasonable because our tech is a simplification of existing strategies. We define future success as scaling 2 more plants, which is again feasible because we can simply iterate from our first plant. And that's the goal we're working towards. To wrap up, our tech and business plan have important implications. 1, we help reduce metals mining, which is linked to violence, child labor, and environmental damages. 2, we support consumer recycling and prevent LIB waste leakage, which would have caused disproportionate harm to marginalized communities living near landfills. And 3, we support the circular economy, the EV industry, and solar power through battery storage. We're generating jobs at our recycling plants, supporting the workers who may lose their job in the energy transition. And this is all on top of the GHG reductions and increased worker safety associated with our recycling methods. We're eager to play a role in the transition to a green circular economy. And with that, we're now open for questions.
If I understood properly, you're trying to make battery recycling inexpensive in the United States, and you're using better processes, but at the same time, you're kind of selling a commodities product. How do you kind of get over some of the kind of market constraints that have nothing to do with your actual technology? Just thinking about the recycling markets that are international and who don't have the same sustainable practices that you will have, but there's not necessarily a way to track bad behaviors.
Let me just make sure I understood your question correctly. So are you asking how we as a company would handle international competitors?
Yes, for
Okay.
a commodity product, yeah.
Yeah, I think the answer is a lot of recycling, at least for lithium ion batteries, is pretty like localized. So like Asia, as we mentioned in our presentation, has like a specific kind of recycling of like hydro, whereas the US currently uses pyro and ours is entirely different. And a big problem actually is not necessarily the technology, but rather the aggregation of the batteries. And so when you look at recycling, there really isn't any international competition. Like Asian recycling companies aren't coming into the US and fighting for feedstock because there are different markets that keep them pretty segregated.
Got it. And then in terms of a follow-up question on some of the ESG impacts that you're having, what tools are you tracking or passing on to your downstream customers to showcase the value propositions that you're bringing?
Yeah, that's definitely something that we have to think through. And I think there are a lot of different ways to do it. I actually do a lot of Scope 3 emissions research. And so one way to do it would clearly be, we track our carbon emissions throughout the process of the recycling, right? And with that, we'll actually be able to create like this is our carbon impact, or this is the embedded carbon within this cobalt as a result of the recycling process. And that's definitely something that we can be handing off to our investors or our purchasers of cobalt as like a sign. And there exist a couple of different ways to track the fact that we are accurately carbon accounting. And one of the bigger ones is going to be like the GHGP. And so we can definitely make sure that our accounting practices are going to be compliant with the Greenhouse Gas Protocol Scope 3 emission measuring tracking.
Small question for you. You mentioned selling cobalt and feedstock at a premium. Is that premium pricing?
So there are kind of two parts to that. We're selling cobalt at a premium. So we're receiving a higher market price than current market prices, but we're paying aggregators a premium to guarantee that we get a reliable feedstock. So both are premiums, but different directions of money.
So the question is then, how much does the operational margin of the business change if that premium goes away?
Which
Evan, want to take
premium
this?
are you referring to here? Both of them?
Either, yeah.
Yeah, so using the Everbat model, which was developed by Argonne Lab, there were no premiums taken into account, and that means $28 million annually in revenue. If we are to add on the additional revenue that we gain by having a markup on cobalt, that brings us to 44 million annual revenue. And then if we add on the additional things of us selling lithium at a discount and paying more to obtain feedstock, that brings the overall annual profit down to around 40 million. So either way, we beat out the initial modeling.
So it goes from a baseline of 28, and then that 40 is sort of what's optimal at various pricing mechanisms.
Yep. Yeah.
Cool.
Thank you.
How long would it take to break even on the cost of a plant?
It's pretty fast. So we mentioned that it takes around 4 million to at least start up the plant. Throughout the lifetime, we incur, I think, 82 million, but our annual revenues are, what was it, like 400 million? And so we're recovering our startup costs pretty quickly.
Good, thank you.
Okay, thank you so much.
Thank you.
Hawaii Innovations, you are next.
Great, and as they come on, I have another joke for you all. Why can't you trust atoms? Because they make up everything.
All right, Hawaii Innovation, you are ready. Your 10 minutes starts now.
All right, awesome. Aloha and hello, everybody. We are Hawaii Innovation Lab, proud to announce Water for All, a deployable solar thermal desalination system. Earth's surface is about, oh, wait. I think we have a problem. It's not advancing.
You might have to click on the slide first, and then you can use arrow keys. I had that issue at first.
Okay, let me try that. Oh, there we go. Earth's surface is about 71% water, and despite this fact, lack of water is becoming an increasingly predominant global issue. According to a UN statistic, approximately 850,000 people die annually from dehydration. To add insult to injury, the majority of these deaths come from the 84 million people who are forcibly displaced, also known as refugees. And while many of these refugees live in refugee camps, the sad reality is that the majority of camps can't actually afford standard water production systems that are capable of handling their water needs. We propose a system that will generate water for these refugees, all while being affordable and feasible for camp administration. This system is deployable and off-grid, allowing for a quick and easy setup wherever it's needed. And by deployable, I mean that the system can actually be set up and begin water production within a single day. This system also has a low price point and low maintenance costs, meaning that water production is now within reach for refugees. And now introducing Water for All.
Our product is a parabolic trough solar thermal desalination system. The water evaporation takes place inside a uniquely designed receiver tube, and the vapor is condensed by passing it through a saline water reservoir. The heat is passively recovered while generating potable water. The parabolic trough is made of aluminum bag with liquid metal polymeric film as the reflective coating, which has a higher specular reflectivity than aluminum and lower than silver. The design allows passive heat recovery from the vapor and brine without using any heat exchanger. The system can process both seawater and brackish water. The recovery ratio of fresh water is 25%. Moreover, the heat from the brine is passively recovered and disposed off to the ocean. Due to the small-scale nature of the plant, brine disposal doesn't have a significant effect on the environment. A 5-trough plant is designed to produce at least 1,000 liters of potable water in a day at a rate of 25 liters per square meter of the reflective surface for solar irradiance of 4.8 kilowatt-hour per square meter per day. The specific water productivity of the system is 5.2 liters per square meter per hour. which is 40% higher than the average specific water productivity of conventional thermal desalination systems, such as multi-effect desalination and multi-stage flash desalination systems.
Our customer segments are coastal refugee camps and humanitarian organizations. We interviewed over 50 potential customers, and many of them have expressed interest in using our product, including the Rohingya refugee camp, whose manager expressed interest in not only a partnership, but also in providing land for the pilot project. And following our expected success at the Rohingya refugee camp, we'll use this success to reach out to humanitarian organizations and other refugee camps and to demonstrate our feasibility at their locations. And therefore we will acquire additional customers. The total available market for solar desalination is about $1.84 billion, and with a 36.6% share of solar thermal systems, our serviceable available market is about $736 million. Our estimated serviceable attainable market is about $36.8 million per year, because we believe that we'll be able to capture about 5% of our serviceable available market. We've compared our system to the current industry leaders in small-scale desalination, as depicted here. All of our competitors have recurring costs, which make them less feasible for end users with scarce resources. Additionally, our system operates fully off-grid, using primarily the sun's heat and for desalination and a photovoltaic for the pump and the sun tracker. This feature is shared with only one of our competitors. Third, our system is easily deployable, so much so that it can actually be set up and begin producing water within a single day. I think I mentioned this before. 3 of our competitors are also easily deployable. However, the difference is that none of them are functional within the same day that they're deployed. Competitors in this industry compete primarily on the fronts of production and price. Here we have a table that displays those exact metrics for our product and for our competitors. At a price point of $3,600, our system has the second lowest price after F-Cube Limited. However, F-Cube Limited only produces 100 liters of water per day, compared with our 1,000 liter daily output. Solar Water Solutions has a similar water production, but at a much higher price point of $8,500. Trans Water System has nearly 3 times our output, but at a much higher cost, which may not be feasible for our target market of refugee camps and camp administration. Now, graphically, this is what a comparison of production and price looks like in the solar thermal desalination industry. High producing products are also priced higher, and low producing products are priced lower. There is no market for high cost, low production systems, and therefore it makes sense that not too many companies operate within this quadrant. The gap in the market is right here. There are no systems that are high producers with low cost. And this gap in the market is exactly where Water for All is positioned. As mentioned before, Water for All costs as little as $3,600 to consumers and produces a solid 1,000 liters of water per day. Knowing that our sales price per unit is $3,600, let's talk a little bit about unit economics. Our expected cost to manufacture a unit comes in at about $2,000, and our estimated customer acquisition cost is roughly $400. This brings us to a total cost of about $2,400. With this in mind, we expect to see a profit margin of about $1,200 per unit. Our revenue model consists of straight income, which is basically what our team manufactures using our own facilities, and from our sales and licensing rights. We plan on selling approximately 550 units annually, which we will produce at our company-owned facilities. And with a profit margin of $1,200 per unit, we expect a sales income of about $660,000 per year. We also plan on licensing out the rights to manufacture the Water for All system with a 35% royalty per unit sold. And this would yield a per unit profit of about $420. Now, we conservatively estimate that our manufacturers will sell about 5,000 units, meaning that we expect to turn a $2,100,000 profit annually from licensing. Now, in our first 10 years, we expect to see a licensing revenue of roughly $30 million and a sales revenue of about $6,800,000. And therefore, we estimate that we will be able to capture our serviceable obtainable market of $36.8 million in 10 years. Now, in order to achieve this highly ambitious goal, we've assembled a qualified team consisting of myself. I'm a senior business student at the University of Hawaii and the chief business officer of the Water for All system. Mohammed, who previously spoke, is our senior scientist, and he's also a PhD student. Both of us, along with our team at Hawaii Innovation Lab, consider ourselves to be extremely blessed to live in this beautiful country that we call America. And this gratitude turned into a drive to improve the lives of the less fortunate, those who, are struggling to find just enough water to survive. And I'm talking about fathers and mothers and brothers, sisters, and children. And rather than just sit there and feel bad and kind of brood over that, we decided to actually stand up and take action. And this is why we created Water for All. And it's one thing to say we want to make a difference, and another thing entirely to actually make an effort to make a difference. So in 2020, we completed the design phase of the Water for All system, where we ran simulations and we did a feasibility study of the Water for All system. Were also fortunate enough to secure a contract in 2021 with the Natural Energy Laboratory in Hawaii Authority. They're also known as NILHA. And they're going to provide us about 3,000 square feet of land at the Keahola CSP site to install our systems for testing and for further refinement. So the question becomes, what does the future look like? Well, we plan to complete the R&D this year, which will require approximately $250,000 just for testing purposes, for materials, and for these types of things. We'll carry out the pilot test in 2023 at the Keahola CSP site, or NILHA, as I mentioned earlier, which will cost roughly $500,000 to fund access to the facility and funding of personnel, their living situations, and any materials they may need. We plan to secure a pilot sale to the Rohingya refugee camp in 2024. And if we're successful with our pilot sale, we also plan to give 104 additional units, or sell 104 additional units to the Rohingya refugee camp. And the total cost for this will be about $100,000. And we'll begin the mass production of our system in 2025 if we can raise the investments that I've just mentioned. And this will have an approximate cost of $5 million. I wanted to thank you all very much for your time, and we ask that you join us in our effort to provide water for all.
Thanks for that.
Go ahead, Lou.
Thanks. What are the unit economics in terms of, if you think about the cost per liter of water produced by your method versus other methods?
Are you saying how much would it cost to produce 1 liter of water from our system?
Yeah.
Okay. So the cost is roughly $1, I think, per liter. Correct me if I'm wrong, Mohammed, but that's what the cost is.
Yes. So 1 liter of water will cost $1 to produce.
And then how does that benchmark against other methods?
So other methods can cost $1.50, some of them $2, $2.50. I'm sorry. We meant to say that $1 per 1,000 liters is what we meant to say. Sorry about that. So no others per 1,000 liter can cost as much as $2.50, $3. Some the cheapest ones we found are about $1.75, closer to $2 type of range. And so we believe that by cutting the cost per 1,000 liters down that significantly, we can actually save the refugee camp quite a bit of capital on their end. And so that would make it a much more appealing investment for them compared to our competitors.
Yeah, thank you.
So in terms of the market you're targeting, seems like the equipment needs to be located near a seashore, as well as the sun resource should be effective enough for it to work. So the map you showed earlier in the slide seems like majority of the darkest regions there are in Africa and not so close to the coast. So have you thought about, or have you quantified the actual number of refugee camps your device would be useful for or can work in, which are in the coastal areas and has enough sun?
That's definitely an interesting question. We haven't really quantified the refugee camps that are, or the exact amount of them, but we do estimate that about 30% of refugee camps that we are targeting are within range of the shore to use our system, or within range of a body of water to use our system. So we believe that with 30% of the camps within range of a shoreline or some sort of body of water, we believe that there is feasibility, and a lot of these camps that we've actually talked to in our feasibility analysis have mentioned that they would be interested in purchasing, bulk or large quantities of our Water for All system, if that answers your question. All right, perfect.
I'm in, oh, go ahead. Allison.
That's okay. My question's about value proposition at scale. So how many liters roughly does each maybe average camp need?
Each average camp. That really depends on which camp you're talking about, because camps can range from tens of thousands to millions of people. There, we estimate about 7 liters per family, so it really depends on the camp size, how many people are being housed there. The Rohingya refugee camp, for example, if we were to provide them about 104 units, it would cover maybe 10 to 20% of their total population. So, and the Rohingya refugee camp is on the bigger side. It's not one of the biggest ones in the area, but it's on the bigger side of the area that that it's located in. And so, yeah, so it would be about 7 liters per family. So, yeah, that answers your question.
So like 100 units ish is maybe average, but maybe on the larger side. How are,
about there, yeah.
How are you thinking about, so the competitive, when you look at the competitors, then the larger one, tons, that one, you mentioned sort of they're the high production, high cost, you're high production, low cost, but the price actually, when you look at it on a dollar per liter basis, is actually pretty similar. They're about 3x the capacity and slightly under 3x the price. So they're pretty similar. And if you're getting into the hundreds of units, how are you thinking about that value proposition as you start scaling?
Oh, absolutely. And I actually really do appreciate you bringing that up, because it lets me kind of go over something that we didn't have time to really discuss too much. We do have so I had mentioned, I think a little bit in the presentation, that we have no recurring costs and we're also very off grid. So we don't have to worry about, or the camp administration doesn't have to worry about, replacing parts or getting new filters or plugging into the grid and using electricity, because a lot of camps don't actually have readily available access to the grid. And so there is that feature too, that while it does seem very comparable, like they produce 3 times as much, but they're also 3 times more expensive. At the same time, they have recurring costs, and they also have like the grid they have to power their units from, which both of them can be very cost ineffective for camp administration.
Thank you so much, YE Innovation. That's your time. Up next, we have Pantheon.
As we transition, I'll say yet another joke, but don't worry, everyone, there's a couple teams left. You don't have to listen to many of them, but where do electricians get their supplies? At the Ohm Depot.
I kind of like that one.
All right, Jacob, your 10 minutes starts now.
All right. So, hi, my name is Jacob Kumpon from Claw Industries, and we turn glass bottles into concrete. So I'm going to tell you about what our business does now and what we're aiming to do. So when you place a glass bottle into the recycling bin, it goes to a recycling facility and it ends up in a pile like this. This is called waste glass, and as you can see, it's extremely contaminated with a bunch of paper, plastic, and metal. This makes it unusable for new bottles or anything else. Each year in the United States, we landfill 8.3 million tons of waste glass. That's almost all the glass we use, and it costs operations directors at recycling facilities $200,000 a year. Now, on the concrete side of our business, concrete, like you'd see in a sidewalk, is made of gravel, sand, cement, water. Cement and water react. That's the glue that holds the concrete together. Now, cement is by far the most expensive material in concrete. It makes up 75% of a mixed director's material cost. In addition to this, for every 1 ton of cement produced, 1 ton of carbon dioxide is released in the atmosphere, meaning it's one of the most polluted materials on the planet. At Claw Industries, we are paid by recycling facilities to take waste glass. We then put it through our patent pending process and create Pantheon. And Pantheon is a partial replacement for cement and concrete. For recyclers, we offer a lower cost alternative than landfill and ensure that the glass is actually recycled. On the concrete side, we beat the price of cement. It substantially reduced the embodied carbon of concrete, as well as increased the compressive strength. Now, so far, we've validated this in 19 concrete projects and raised $458,000 in non-dilutive funding. Using that money, we purchased a pilot plant in Binghamton, New York, and received the first delivery of waste glass at our facility in September. We're now scaling to fulfill a 25 ton per month letter of intent for Pantheon starting in April. But we're not stopping there. Our next step is to inject carbon into Pantheon to make the first carbon negative cement replacement for the concrete industry, using a process known as mechanically assisted chemical exfoliation, specifically using nickel 2 nitrate as a catalyst. Now we're aiming for a 15% capture rate, and that's based of alternative materials for concrete such as fly ash. Now, a little bit more about this process. What happens is that Pantheon is pressurized with CO2 and media and is rotated. This allows the microparticles to absorb CO2. And this costs us about $9.60 per ton. Now, you may be asking, where are we going to get all this carbon? Well, we're looking to get it from biomass, combustion facilities. Specifically, we want to remove 1.35 million tons of CO2 each year, starting in 2029. Now, specifically, we are focused on partnering with Taylor Recycling in New York, which is a DOE-funded biomass waste-to-energy facility. Due to their logistical range to us, they serve as a great potential partner. Now, due to the high-volume nature of our business, we service a small regional area. We work with operations directors at recycling facilities that process 2,000 tons of waste glass each year, like Shalene Taylor from Southern Tier Recyclers. Shalene's hit the hardest by high landfill disposal costs. On the concrete side, we work with mix directors in the ready-mix concrete industry who use 3,000 tons of cement replacements each year, like Tim Rufo from Barney and Dickinson, who is trying to lower his cement costs and comply with New York State's Climate Leadership and Community Protection Act. And we helped Tim come in and align with these goals. Now, why else would Tim switch? Well, Pantheon with carbon actually further increases the compressive strength of concrete. Additionally, we leverage an existing ASTM standard, allowing us to not wait for regulation to catch up to deploy this technology. Now, the biggest part of this is that we inject the carbon and there's no other infrastructure that the mix director needs to install at their facility. This is huge because mix directors don't have the time, space, or money to deal with new sources of carbon. Now, our competitive advantage is our patent pending process to remove contamination from waste glass. Specifically, we pull out all those little pieces of paper, plastic, and metal. Now, why is this important? Well, our competitors, Urban Mining Northeast, located in Connecticut, and Tricentrics, located in Montreal, use clean glass as a raw material for their glass cement replacement. Now, our ability to take waste glass allows us to do two things. First, we are paid to take our raw material. This compared to our competitors who are currently paying for expensive clean glass. On the other side, we are able to leverage an 8.3 million ton per year stable supply chain, where our competitors are limited by the volume they can purchase. Now, to put some numbers on this, we take Pantheon for $35 per ton, or waste glass for $35 per ton, and we sell Pantheon for $90 per ton. This affords us high revenue in the early years, but as you can see, we are a capital intensive business, which causes our margins to fluctuate pretty substantially. For some more detail, our cost of goods sold is $81 per ton, including that carbon injection, and logistics is $29 per ton. Now, to go into the sustainability side of things, as I mentioned, for every ton of cement produced, 1 ton of CO2 is released into the atmosphere. Cement production accounts for 8% of global CO2 emissions. That is 4 times higher than the entire aviation industry. So you may have heard of battery-powered planes or high-efficiency jet fuels, which are great innovations, but nobody ever talks about how the runway is 4 times worse for the environment than the plane itself. Well, injecting carbon into Pantheon to replace high carbon cement reduces the embodied carbon of concrete by 67 kilograms of CO2 per cubic yard. So what does that number actually mean in the real world? Well, it means in that residential sidewalk pour we did at Binghamton in the left picture, we would have removed 267 kilograms of CO2. At Clarkson University, we would have prevented 483 kilograms of CO2. Now, those may seem like small projects, but in the Freedom Tower, that would have amounted to 60,000 tons of CO2. Now, your next question probably is, does this scale? And the answer is yes. In the US, we can remove 1.35 billion tons of CO2 each year. Now it gets interesting at the world scale, where we can remove 102 billion tons of CO2 per year. And that's because the US is a very small user of glass compared to developing nations who are also developing their infrastructure at the same time. Now, our role in the energy transition is to deploy low carbon, low cost material solutions to the concrete industry, our disadvantaged community in Binghamton, which has previously been priced out of low embodied carbon concrete materials. To prove this, we have purchased our production facility here and are setting up shop, aligning with the Biden administration's Justice 40 initiative to put federal funds in the communities that need them. Now, our total addressable market in the United States for doing this is $1.3 billion. And in New York, our service obtainable market is 26 million. Now, to actually make this happen, in September of this year, we want to get our initial reactor going. And in September, we aim to do lab testing. In June, we will complete a life cycle analysis and a techno-economic analysis. And in January of 2024, we want to complete field testing and then immediately deploy to mixed directors who are already using regular Pantheon. Now, Claw Industries was started by myself and my co-founders after we toured our local recycling facility and learned that all the glass we had been placing in the recycling bin was currently sitting in our local landfill. From there, our mentors from Clarkson and Binghamton University helped us overcome our business and technical hurdles, as well as define success, which we define as the number of pilots we complete and our customer retention rate. Now, moving forward to make this happen, we need a chief chemist to help fill the knowledge gap we have in our team. And we also require wet lab and equipment space at the Kaufman Incubator. The Office of Fossil Energy and Carbon Management Prize will allow us to hit that September objective and inject carbon into Pantheon. So next time you place that wine bottle into the recycling bin, just remember that it's Claw Industries trying to keep it out of your landfill and use it to lower the carbon impact of the concrete industry. So thank you very much, and I'll open it up to any questions.
So I'm thinking through the environmental impact a little bit. Your technology is displacing cement and concrete, and it's also, you're injecting carbon dioxide into it as well. So if you consider all of those, like what would be the % reduction in carbon intensity of concrete produced using your method versus traditional concrete?
So it's difficult to give a percentage because that's very dependent on the mix, but a number is 67 kilograms per cubic yard. Just to like put it in perspective, that would be close to around a 35% reduction.
Do you know like if there's an upper limit to the amount of cement that your material would be able to displace?
The upper limit is 50%, so we could probably reduce the embodied carbon with the carbon injection. Close to around 60% would be the top out.
Got it, thanks.
So it's a cement kind of replacement. Is it fair to say it's a replacement for the cement product? So have you spoken to customers like construction people who build buildings, and that will they be willing to have this 50% of cement replaced with the product you're offering?
Yes, so we have done that. We've completed 19 concrete projects with mixed directors, and that's what that letter of intent is for, is a concrete plant is switching over to using this material. Materials to replace cement and concrete are generally used in the industry. However, they come from coal power plants and steel foundries, so they're getting really expensive. It's another selling point of our product.
What is the price difference against traditional concrete?
On the material side, we reduce the cost by about 25%. We're about $90 per ton freight on board here in Binghamton.
Are there any seasonal concerns about using your product? Does it work across all 4 seasons? Does it extend, for example, the seasonality of deploying concrete, or is it similar in nature? Like, can you deploy it in cold weather?
Yep. So it doesn't extend the season, but it acts normally in the season. So we've done pours in the summer. That pour at Clarkson I mentioned, that was in November all the way up north in New York. So it works across all seasons.
I've heard of other carbon sequestered concrete aggregates. Would you be able to be used in conjunction with some of those other products, or would this be a head-to-head competitor?
We would be able to be used in conjunction. So, a big thing, like you mentioned, is aggregates. That's replacing things like gravel and sand. We are replacing the cements. We're reacting and adding strength. So I mentioned that 60% earlier to Luke. We could actually combine with those other materials and get really far down. So.
Great. If our judges don't have any other questions, then maybe I'm going to throw it to Joe for another energy joke. Thank you so much, Jacob.
Thank you all. Appreciate it.
Great. So as we transition, I think what I will say is, how do kitchens most often say hello? With microwaves. Someone in the room that I'm with actually laughed, so I guess that's something. Okay.
All right, Fluxworks. Great, your 10 minutes starts now.
Last year, Texas experienced a historic winter storm. Both our wind energy and our natural gas resources were crippled by the cold weather. Water pipes burst, flooding homes, and millions of Texans were left without clean water or power. My 85-year-old grandmother was one of these Texans. For over 3 days, she was left in her home without clean water and was freezing. That day, I vowed to strengthen our renewable energy grid and decouple our reliance on fossil fuels. And how we strengthen our wind energy grid is by using magnetic gears. No worries, my grandmother is still alive today. So let's look at the root of the problem. The root of the problem is that most wind turbines today use a complex mechanical gearbox to save upfront costs. This is the component that can't work in the cold. And even when it's winterized, it still only has a 7-year lifetime, is notorious for breaking down. So offshore, they can't afford these breakdowns. So they use expensive direct drive generators to generate energy, bringing up the cost of energy. And why can't they afford this kind of maintenance? Because the maintenance is an absolute nightmare. It involves completely overhauling the gearbox, building a crane on site, and typically the gearbox is down for 2 to 3 weeks. And this is an enormous recognized problem in the industry. For the $60 billion global wind industry, the National Renewable Energy Laboratory estimates that $19 billion today has been wasted on operations and maintenance costs, primarily driven by this gearbox. And the way the market is growing, they estimate that it will grow to about a $38 billion problem. This is wastes. If we put a magnetic gear in a wind turbine, which can be retrofitted to existing wind turbines, we can reduce the levelized cost of energy of wind by 15%. They also have an incredible overload protection property. They can survive any gust of wind and can keep on operating. The magnets just slip past one another. Thus, they're ultra reliable. And by being lubrication and contact free, they can work in any temperature. And where they go is they replace this complex 3-stage mechanical gearbox with our simple, patented, single-stage magnetic gearbox.
And our magnetic gears can service 2 key markets perfectly. They're great for small-scale 100 kilowatt wind turbines, as well as large-scale 8 megawatt on and offshore utility-scale wind turbines. The total lifetime cost of a 100 kilowatt sized wind turbine is roughly around $220,000. Of that, manufacturers have to set aside $95,000 solely for the mechanical gearbox and the total lifetime operational maintenance cost associated with it. That is roughly almost half of the total cost of a wind turbine. And this is where magnetic gears come into play. With a magnetic gear, we can reduce the total cost by around 6%, bringing the $220,000 to $207,000. Now, upfront, magnetic gears are slightly more expensive, but where they truly shine is in their operational and maintenance cost savings, bringing down the cost by around 35%. This is where we get our 6% savings. Another great feature of magnetic gears is that they scale upwards as the power wattage scales. So in an 8 megawatt wind turbine, we're able to reduce the operational and maintenance cost by $1.5 million. That is a total savings of around 15%. Some of our current competitors are mechanical gear manufacturers. They're primarily based out in Germany and China, And again, they are mechanical gear manufacturers, so they're prone to that 7-year critical failure.
Now, magnetic gears are starting to get global attention, and 2 startup companies have shown up, but Flux Magic has only achieved 40% efficiency with their complex 2-stage magnetic gearbox. Magnumatics out of the UK has taken a different approach, and they went for a low gear ratio. Now, wind turbines prefer very high gear ratios, typically 200-to-1. This results in just marginal improvement. And they estimate that at the 10 megawatt offshore scale, they can only reduce the levelized cost of energy by 2.6%. So what Fluxworks' competitive advantage is that we have exclusive access to intellectual property invented at Texas A&M University that can achieve 96% efficiency in a single stage and can achieve a whopping 200-to-1 gear ratio. This results in a disruptive 6 to 15% levelized cost of energy reduction. Also, our team at Fluxworks boasts having 16 plus years combined magnetic gear research and development experience.
Our company plans on having various different types of revenue. Initially, we plan on selling our 100 kilowatt size gearbox to various wind turbine manufacturers. We also plan to sublicense our IP to large scale wind turbine manufacturers, companies like GE, who specialize in 8 megawatt size and greater wind turbines. We also want to sublicense our technology to marine energy. This is because the reliability of our technology will finally allow us to harness the potential of our oceans and rivers.
And energy is not the only sector where magnetic gears have an incredible value proposition. For example, in aviation, where we're trying to make it fully electric, there's currently a huge noise problem. And with magnetic gears, we can reduce the acoustic noise by 83%. So this is why we plan to target the aviation industry as well. And as the only US owned and operated magnetic gear company, our competitors are both foreign owned and operated, we can be a sole provider to the government for silent drone motors. Now, this is not just IP that's an idea on paper. The Fluxworks founders actually have experience developing it at the large scale for energy resources. For example, in a $2.5 million Department of Energy funded wave energy project, the Fluxworks founders in the past have partnered with ABB Corporation and Resolute Energy. In each of the areas that we've discussed, Fluxworks is already gaining traction. First, Amazon Prime Air reached out to us in November, and we're still in negotiations for a contract to develop magnetically geared motors to make their drone delivery platform silent. Emergy, a wave energy converter company, is also interested in magnetic gear technology, and we're assisting them with a water power technology office funded project. General Electric, already giving us a letter of commitment and is committed to providing cost share, we're currently partnering to enter into a Department of Energy funded research and development project to develop and de-risk magnetic gear technology. Now, Fluxworks is not just about making money and increasing profit margins of companies like GE. As a HubZone certified small business, we are passionate about creating American manufacturing jobs in our community of Bryan College Station, Texas, where there's a large number of historically disadvantaged peoples that don't have these kind of job opportunities. Globally, by reducing the cost of wind energy, we will expand access to clean and renewable energy for impoverished communities, which have historically relied on harmful fossil fuels. As for our role in the energy transition, with a fully US supply chain, we will strengthen the US energy supply chain. And with our wind turbine reliability, you can rest easy in the increased security of our carbon neutral grid of the future. And as we reduce the cost of energy and increase reliability, this will lead to faster global wind energy adoption.
And as the wind market scales, so will our company. After our primary production of our 100 kilowatt sized gearbox, we predict that we're going to have a net operating profit after taxes of around 17% increase year over year to perpetuity. Assuming that we will be able to create 12 gearboxes a day, 5 days a week, at first year, we assume we will create 3,000 units at a sales price of $38,000 with a conservative industry growth rate of 5.5%. Some analysts have projected this to be anywhere from 9 to 9.5%. So with this conservative growth rate, we estimate our company has an enterprise valuation of $340 million. Here, we have further broken down the cost of our 100 kilowatt magnetic gear into 5 segments: materials and tools, labor, indirect costs, general and administrative, and a 7% profit margin, which gives us our total of $38,000 per magnetic gear.
So how do we achieve sustainable full production that my partner Daniel was talking about? Well, that begins in 2027, and there's 4 phases that will happen to lead up to that. In the first phase, by winning the EnergyTech UP competition, we can take our world patented technology and convert that patent to utility, first in the US and in many European countries. Then, in partnership with GE, we can develop our 100 kilowatt technology by pursuing DOE and ARPA-E funding. Then we'll move into pilot testing. There are in-rel 100 kilowatt test turbines where we can capture key important data to de-risk the technology. Then after a VC Series A 20 million funding round, that's when we can begin low volume production in 2027. Now, as for developing out the 8 kilowatt wind energy converters and the 500 kilowatt wave energy converters, this can be broken into 3 additional phases. First, the R&D, then the pilot testing, and then moving into sub-licensing with our partners. And it will be important to maintain a continued relationship with the companies that we're sub-licensing to. And that's why beyond phase 7, we continue to provide consulting and R&D services to these companies. My name is Brighton Preslika. I'm a PhD student specializing in magnetic gear technology. I've built 5 prototypes to date, and I've filed 4 accepted patents. This is Daniel Zamaron. He's an MBA student, also filed 1 patent, and is a US Marine Corps veteran. And Professor Hamid Toliat, our chief scientist, is a world-renowned professor of magnetic gear technology, known widely in the motor and magnetic gear space.
Don't shut the lights out on this wonderful opportunity to support a company that's going to bring affordable, reliable, and clean energy. We are Fluxworks, and thank you for your time. So for the aviation use case, I'm trying to understand, are you, this gearbox, will it go on top of the traditional motors, or will you be designing a motor itself which takes this new gearbox?
Yeah, great question. So typically in aviation, they use direct drive motors. And with magnetic gearboxes, you can either add them in series or integrate them. We have patents on the integrated topology. And the value proposition is that currently with direct drive motors, the drones can only be efficient and reliable, but they can't be low speed. It's when they start spinning fast that they become too noisy. So magnetic gears reduce the speed while maintaining the same weight.
Will speed reduction not cause issues with the speed of the drone itself, maneuvering speed?
Yeah, that's also a difficult topic to understand when you're not familiar with the field. So think of when you're in the pool and you lay your hands like this, you don't move very much water. It's not very hard to move. But then if you tilt your hand, you increase the pitch, then you capture more wind, but also you put more load on your hand. So essentially you just create a different propeller with slightly higher pitch. Then you get the exact same amount of thrust at a lower RPM.
I see, thank you.
Are there any other questions? Any other questions for Fluxworks?
I'll ask, when you're thinking about scalability, it looks like a lot of what you're planning to do is partnerships, and you've already engaged with some OEMs. Outside of that kind of testing, what are your other kind of limiting factors as it relates to scalability?
Yeah, so as for building 8 megawatt scale wind turbines, the facilities required are somewhat immense. So the reason we chose the sub-licensure path is because the way a magnetic gear works, it's actually extremely similar to today's direct drive permanent magnet motors that GE already makes. So there's 3 main components in a magnetic gear, and 2 of them are identical to what GE currently makes. And there would only be 1 additional part, that's the patented part. For this one, we would either sub-license the IP for them to manufacture on their site. It's very simple to manufacture. The manufacturing looks sort of like a cookie cutter, except instead of making gingerbread, you're using a 50-ton press to cut steel. Or alternatively, we could develop the infrastructure just to make this 1 component and then sell that component to them for them to integrate, rather than us trying to build GE-sized infrastructure and making the same relationships that they already have with wind turbine operators.
Thank you.
So thank you, Fluxworks. We appreciate having your presentation at the end of today. So I am here to give our sort of final close out for today. That is the end of our presentations. And I want to say thank you very much to all of our competitors. You can see the lighting has even changed because we've been together for so long today. I want to say a special thank you to all of our teams for spending the entire day with us. We certainly appreciate having you here. We want to say a special thank you to our judges as well. And I want to make sure that all of our teams are filling out the questionnaire. So in the chat, earlier today, we put a form so that you can give us feedback for the presentation, for the experience that we had together. And before we get to sort of our final couple of comments, I'd like to have all of our judges put their cameras on and just ask if there are any final thoughts, questions, insights, perspectives on today's presentations. Who'd like to start? Sakshi, please go ahead.
Okay, thanks, Anna. So first of all, thanks for the opportunity to be here and to listen to all the great presentations. One thing to mention would be students have really put together strong business plans, and that's something I observed, and that was one of the primary reasons the competition was made, to encourage students to think through that. And it's incredible to see that how they are thinking around the core technology, that how can it be brought to the market. So in terms of the technology itself, new things for me to learn. I learned a lot as well from students, and in terms of the business plans they have put together and how they are thinking about bringing it to market, and that to like different sorts of, from nuclear to cement manufacturing, the breadth of the technologies which can address climate change from different directions they have presented is definitely fascinating. So yeah, great presentations.
Thank you. Any of our other judges?
I really appreciate all the effort that everyone put into making their technology really accessible and understandable. Some of you have PhDs that you've been working on years on a really specific topic, and you broke it down in a way for the layperson to understand. And on top of that, the effort it took for you to get to this stage after competing on the regional stage. I just want to encourage everyone to continue working on these technologies. Just the sheer decarbonization that will take place if all of you launch into commercialization will be significant. And I'm so excited that you all are at the helm of the next stage. Thank you.
I just want to say thanks for, asking all of us to participate as well. I've learned a tremendous amount in the last, 48 hours or so since starting to see all the things that you're working on. I echo what my colleagues said. I mean, the work that went into this is incredible. These are real businesses. It's not often you get to judge really sort of early stage pitch competition type things and have really actual businesses that are definitely scalable across every single pitch. And so keep working on these, because I'm fired up about what the future of climate change could look like if these ideas and your future ideas and everything that you're going to do get commercialized. And I'm just excited for everything that you're going to do.
Yeah, all of the above. I didn't realize like some of y'all are like college students. I don't think when I was in college, I could put together half as good a business plan as y'all have put together. So massive kudos there. And it was so cool getting to see you guys. The companies were at definitely very different stages that we saw today. Some were just proof of concept stage. One was even raising like Series A funding. So I just want to say, like, even if this opportunity doesn't work out, there's so much funding going into climate tech these days that I'm sure there will be other opportunities for you.
Yeah, and I would just say thanks to you all. When we started this program, we weren't sure if it was going to work, if people were going to apply, or if this was the right way to do it. And I think just watching you all pitch was really inspiring and really showed all of the work you're doing and all the impact that you can have by focusing your efforts on thinking how to commercialize energy technology. So thank you for working on these issues, and hopefully we can continue to work together in the future after this program.
Thank you, Victor. So we have just placed the questionnaire link back in the chat again. So please do make sure that you fill that in. Incredibly helpful to have that feedback. And that feedback is going to go directly to Joe Simon, Katie Smith, and Jackie Petrie at NREL. I want to make sure we give them a shout out for the incredible work that they've put behind pulling this event together as well. Thank you all judges for not only your time, but those important comments. So I do want to remind you that tomorrow afternoon, we have two events that are happening as a part of CMU Energy Week. So one of them has a QR code that you can register for, but I do want to make sure that you're aware of another, which is if you join part of our American Made Solar Prize hardware competition between 3 and 3:30, we're hosting a panel that includes investors and some experts, and they're going to be talking about some of their reflections from this week. And one of the judges for this competition, Sakshi, is going to be on that panel tomorrow. So she'll be sharing some of her overarching reflections. And then finally, the networking mixer, which is the final event of CMU Energy Week 2022. We will have table hosts, so you'll be able to quickly identify some national competitions, investors, et cetera, who are at that event. Plus, you'll just be able to meet each other. You'll be able to meet other future employers, future employees. We're really excited about that event. And we will be announcing the winners of the EnergyTech UP during that event. So with that, I think I'm closing out for us today. Judges, you will be deliberating in a separate room. So I want to make sure that you all know to switch over to that. But for the rest of you, have a wonderful evening. We will see you back here tomorrow, and have a good night. Thank you. Thanks, everyone.
Thanks, everyone. Thanks so much.